Hey everyone, this is Aanshul Sadaria, software engineer at Google. In this video, we will start from scratch with C++. We will talk a little bit about what programming is and what are the real life applications of programming, and then we will jump directly into the basics of C++. But before we do that, don't forget to check out Scalar's free masterclasses taken by industry leading experts only on Scalar's event page. Link is in the description below. Now let's get started. So now let's begin with a very fundamental question. What is programming? Okay, programming is, to put it into very layman words and as well as like keeping a cliche technical definition, program is a set of instructions. Okay, set of instructions which are executed by a machine. Now, if I want to compare it with a real life analogy, for example, whenever my mother goes out of town, what she does is she lays out a set of instructions that when you wake up, take milk from outside, boil it, put it in the refrigerator, wake up your sibling and so on. Like there are a set of instructions provided to me which I need to fulfill. Obviously, being human beings, we don't execute them to the perfection and with 100% accuracy, but we expect the machines to be 100% accurate and not think on their own. Obviously, I'm not going into the artificial intelligence side of it, but machines are expected to follow whatever instructions we give to them. So these set of instructions is what makes up a program or a code. Okay, so that is what program is, and the art of writing a program is what programming is. Now it's important to understand that programming is not just restricted to the computers. Okay, you might be taking flights or you might be going by cars, so programs exist there as well. Like wherever you go, whatever part is automated, there a program is existing. For example, let's say you are a cricket fan. Okay, now you are watching World Cup. Okay, now whenever a player takes a DRS, okay, decision review system. So whenever a DRS is taken, so there is a sneakometer, there is Hawkeye, and all those different angles of cameras are there, and then a decision is taken. So programming exists in all those things. Like sneakometer is a technical thing where a program is driving that particular piece of software. Okay, hotspot used to be there once upon a time. So in that also there used to be some sort of a program underlying. Now, if you are a Formula 1 fan, you would have known how the sport has evolved over a period of time. There are tons of sensors everywhere on the Formula 1 track, in the Formula 1 cars as well. All the data is collected and then analytics are done on top of it. So programming is going to encapsulate the entire world at some moment in future. It has already started to spread everywhere and anywhere. So those are, like, just to give you a little detail, like that is what programming means, and those are the real life applications of programming. So now moving on to the main part, I don't want to bore you with a lot of theoretical stuff. Now, what are programming languages? So you can use different types of, for example, like someone speaks in Hindi, someone in English, and someone uses their own like different regional languages. They want to try and communicate the same thing in their own language. So similarly, programming languages, all the programming languages are meant for a program execution, but they can be written in different languages. For example, there are languages like C++ is there, Java is there, Python is there, JavaScript is there. And just to give you a fair idea, there are obviously more than hundreds of programming languages at this stage. Some of them have become obsolete, some of them are trending nowadays, some of them are meant for a particular use case itself. Now to talk about Python, like Python is a very versatile language. You would have seen its application with anything related to data. Machine learning is there, deep learning is there, artificial intelligence. Python provides a lot of frameworks related to that. So people who are into data analytics, they are very keen to use Python as a programming language, or perhaps SQL as well. Now, JavaScript. The entire World Wide Web is wrapped around JavaScript. Whatever client-side server you are looking at today, it has a flavor of JavaScript in it. Okay, like front end part, whatever the client side of, like there is server side, then there is client side. So whatever client side programs you are looking at, there is a flavor, there is a touch of JavaScript in it. And Java and C++ on the other hand, they are server languages. Like you can use Java and C++ like languages to create your backend servers. Java can also be used for app devs, like you can use Java native or you can use Kotlin, which is built on top of it. So it has applications in application, like app dev, whatever mobile applications we are using, and normal web servers as well. And same goes for C++. The benefit with C++ is that it's a fast language. It's closer to the hardware and it is more performance efficient as compared to Python, which is built on top of C++. Okay, so we'll talk a little bit about what are the benefits of C++ because this module is all about C++. And my favorite language is also C++. If you have checked out my podcast about different programming languages, you would know how much I love C++. So this is performance efficient and this is also server-side language. Now, I'm not going to waste a lot of time talking about different programming languages when this module is meant for C++ only. Now, introduction to C++. I want to capture the essence of C++, like how C++ was born, just take a brief understanding of what was the requirement, why C++ was needed at that point in time, and then obviously, as I told earlier, I want to explain why C++, okay? What are the benefits of C++? So why don't we start with the benefits first and then we look at the history. Why C++? The first thing, it's closer to hardware, okay? Closer to hardware. It is a low level language as compared to Python, okay? It's not a machine level language, but it sits quite nearer to hardware as compared to other programming languages. Closer to hardware, and hence it is performance efficient. Performance efficient. To put it into basic word, it's fast. It has speed. Okay. So wherever you want the executions to be fast, for example, you would look at trading firms. Okay. They want their orders, stock market orders for equity, future and options to be executed real fast in real time. So they would prefer to use C++ as their language for the infrastructure. Okay. Now those who are doing competitive programming also, they would be aware about the benefits of C++ and how closely it is related to speed and execution. So now, since it's closer to hardware, there is another benefit, which is the flexibility. Now you have more control over how you are managing the memory, how you are managing the allocation of memory, garbage collection, and all of those features are more in hands with you as compared to some other programming language. Okay, so memory management. Now, some people would consider it as a con as well, that you need to take a look at all of these things on your own, whereas in Java, garbage collection, memory management, all of that is handled by the language itself. So it depends on your use case. If you want that flexibility, if you want that control over memory allocation, garbage cleaning and all of that, C++ can be a good language. If you are too much concerned that how can I do this, I don't want to manage this part, then you can choose other language like Java as well for your server-side development. So memory management is in your own hands. And the main part, like I will talk about it in like the conception of C++ as a programming language. It is an object-oriented programming language. Okay. Which is a big plus and a reason why C++ as a programming language was born. Okay, so this allows the real life entities to take shape in terms of programming languages and data structures, like object-oriented programming. Like I will be covering a module for that as well to talk about the basics of object-oriented programming in C++, where we'll cover it in much detail. But for the time being, let's just keep this in mind. Why C++? It's because it's an object-oriented programming language as well. Now looking back into the late 20th century, okay, the history of C++ development. So in 1979, there was a PhD student who was working on his thesis, which was about some simulations. Okay, I don't have in-depth understanding of what he wanted to do, but he was working on a programming language named Simula. Okay, so as the name suggests, he had some work to be done in the lines of simulations. And Simula at that time was one of the primitive languages, primary languages, which dealt with object-oriented programming paradigm. Okay. So Simula was an object-oriented programming language. Now at that time C++ didn't exist. Okay, C as a programming language existed, and with C it didn't have any object oriented programming paradigm involved in it. So C was fast, okay, and Simula was not fast. So now this person who was pursuing his PhD and he was writing his PhD thesis, he thought, how about making changes to C as a programming language so that it becomes object-oriented programming. So now you will have both the pieces of cake, that it's fast as well and it's object-oriented programming as well. So that's how C++ as a programming language took birth. This person started working on it, and then at that time it was called C with classes. Okay. So some people would say that C++ as a programming language was born in 1979 when this person started working on C with classes. But it was actually in 1983 that C with classes was renamed to C++, and then the first edition was published in 1985. And then there came on a flurry of different versions. I'm not sure what version is going on right now. Perhaps it's C++ 20 or 23. I think 23 is still in beta, or I'm not aware because I have lost a touch with C++. I have been coding in Python for last few months. So C++, a lot of versions keep on getting rolled out, and the main benefit of C++ is the community support. Okay, so let me just add that up in the Y part as well. Along with the speed, along with the object-oriented programming and all of that, community support is a big plus. Like lots of programmers code in C++. So if you have any doubt, if you have any confusion, you can use platforms like Stack Overflow and all of those platforms to get your doubts clarified. And the documentation is obviously top notch. Okay. So community support is something why I like C++ a lot. Community support is rich. Okay. So now we have covered the history. We have also covered what are the advantages of C++. Now let's move to the main part, why we are all excited. We will start coding in C++. We will understand the structure of a C++ program. We will write and compile our first C++ program. So to all those who are beginning with C++ as a programming language, we'll start from scratch. Okay, so you need not worry anything at all that, hey, I don't know the syntax of C++. Hey, I don't know how to write a program, how to compile it, how to execute it, and so on. We will start everything from zero, and then we will build the basics. So let's first understand the C++ code structure, and then we will write our first program. Now, this is what a code structure looks like. It may be overwhelming, but don't worry, be with me. We will go pace by pace, slowly trying to understand what all these things mean. Okay, so the first part is header declaration, or including headers. Okay, don't worry what headers are. We will talk about that as well. At this moment, let's just understand what all different portions are there in a C++ program. Okay. So what is necessary is this int main function. Don't worry what a function is as well. We are going to cover that as well. So int main function is really important because when we execute our program, the compiler or like the binary will look for the int main definition, and the execution of the code will start inside it. Okay, whatever code is written inside the int main function, that is going to get executed. So this is really important. Without the int main function, your C++ program can't get executed. Okay, don't worry. If you don't know what is int, what is main, what is return 0, step by step, we will understand all of it. But at this moment, just understand your program will not execute without this. No execution without this. Okay, now let's just take a step back and understand why headers are needed. Okay. So as I told you, a lot of work has already been done since the 1980s on C++. So you need not write all the code on your own. You can take use of the libraries which are already existed. Okay, let's say you want to find out max of two numbers. Okay, so the code for that already exists. You don't need to rewrite that code, and this code is present in some libraries which we can include using their headers. So that is where the headers come into picture. You can include the respective headers for whatever utility your code requires, and then you can use it directly without having to copy paste or write it again. Okay. So that's where the headers come into role. If you don't need to, like, if you don't require any utility from outside your code, it's completely fine. You don't need to include it. Okay, this is not necessary. First of all, this is not necessary. And then there are some namespace declarations, and there are other class and function definitions. At this moment, don't worry about it. We are not going to talk about this in detail, and you won't require it for this particular module. But just to give you a hint that such, apart from the headers and apart from the int main function, there can be a few namespace declarations, and there can be a few classes, few functions, and these elements can exist in your C++ program. But for the time being, we are not going to dwell into all of that. So this is also optional. Once again, this is not necessary. All right, now this is how the structure of a C++ program is broken down into. Now let's move on to writing our first program. Okay, now this is how compilation takes place. I will explain that, but let's first write our code. What I'm expecting from you is that you have access to terminal, either it's your MacBook or you are using a Linux machine, or it can be any other machine. So this is what a terminal would look like. And using this mkdir syntax, I'm going to create a folder. Like in programming words, we call it directories, which is equivalent to folders. Okay, so I will just name it intro to C++. Okay, now using cd command, I can move to intro to C++ directory. Okay, now I'm using a Sublime text editor for writing my code because it's one of the most basic ones. But if you have access to Visual Studio or any other sophisticated code editor as well, feel free to use them. They are very powerful. Okay, I'm not recommending this particular code editor to anyone. It depends on your use case. It depends on whatever your muscle memory is and what is more comfortable to you. Okay, so now I will just write intro.cc. Now cc is the extension of C++ programs. So, okay, I wrote into intro.cc. Okay, now we'll start writing our first code. Okay, let's just move back to the syntax and let's start adding pieces step by step. Okay, so headers are not necessary. The namespace declarations and other classes are also optional. And what is necessary is the int main function. Okay. Now don't get overwhelmed by what return 0 is doing over here and so on. We will be covering about that. We want to print, like, okay, what is going to be our first program? Our first program is going to print hello world, which is usually the first program of other software engineers as well. Like my first program was printing hello world. Okay, so we want to print hello world. Okay. So for that, we are going to use a utility provided in some other library, which is cout, which is used for printing outputs on the terminal. Okay. So we will cover cout in detail when we are talking about input and output streams. But right now it's important to understand that cout is used to print something to the terminal. Okay. From memory, it goes to the output device, whatever device we are using. Over here, it's a screen, it's a terminal. Okay. Now we are going to just write hello world, and then we will add a new line. Okay, we will cover what a new line is as well, but let's just try to compile the program. Okay, now G++ command is used to compile a C++ program. So intro to C++, we will try to compile. Now over here, there is an error. It says cout was not declared in this scope, andl was not declared in this scope. Okay, now what it means is that we used some utilities which were not defined in our program, and since I know I used it from some other library, we are going to include it as a header. Okay, so let me just include it. Hash include. Now the header is iostream. Okay, so now it should get compiled. Now if you see, again, it's giving an error and it says cout was not declared in this scope. Did you mean std cout? Now what std is, it's the standard template, it's a standard library which we should be using, like that's the namespace. So if you remember the structure of a C++ program, there can be some namespace declarations. So using namespace std will sort this thing for us because we are using the cout and endl utility from the std namespace. Okay, so this is just to tell the compiler that, hey, if you find something which is not using the namespace explicitly, we are using a namespace std, and please try to check if it exists in the std namespace or not. There can be more than one namespaces, but over here we only require one. Okay, now it is compiled, and now let's try to execute it. So before that, let's take a look at what the different files are inside this directory. So intro to CC was our main code, and a.out. This is the executable which is created when we compile a C++ program by default. Okay, so now I will just write the name a.out, and then this should get executed, right? You can see hello world on your screens, and it executed our program as it was intended to. So now you might be wondering how the compilation and everything took place. So let's take a step back and try to understand this entire process a little bit. So this is our source code. Okay, prog1.cpp. This is an example flow. So over here, our name is intro.cc. You can use cc as the extension for a C++ program. You can also use cpp as the extension for a C++ program. Both of them are fine. Now, the first step is pre-processing the code. So there is a preprocessor which tries to expand the header files that we have included. So if you notice, we used a header file by using #include command. Okay, #include statement. So we did iostream, which was used for endl and cout. Okay, so now when we add a header file in our program, it refers to some library which is already there in our C++ corpus. So it tries to fetch that particular code and tries to expand it. So now if you were to look the file, like how it looks after the C++ processor processes it, it will just write the entire code of like whatever was there in iostream library. It will try to expand the entire code and put it into our file. Okay, so this is like, that's how pre-processing happens. And then it says that it's an expanded source code file, what I talked about. It's a temporary file and can be printed as well if we wanted to. Now here is where the compiler fits. Now you might be wondering that entire process is called compilation, and then there is a sub process within it where the compiler actually executes. So that's right. I mean, even though the entire process is known as compilation, this is where the actual compilation happens, and then there are some other processes associated with creating an executable file. Now compiler creates the source code after pre-processing into an assembly level language. Okay. Now .s is an assembly level language. Now this is not exactly a binary code. This is not a executable file. It converts it into a language which is closer to the hardware. There would be some instructions about how the data needs to move from one register to other register and how the hardware needs to execute it. Okay, so this language is understandable by the hardware. Now assembler runs on top of the assembly level program and then converts it into an object code, which is what is going to be executed. So this is a binary program which we can't understand. Okay, humans can't understand it. Assembly level is still understandable by humans and machines, both of them. All right. So the first two files, source code file and expanded source code file, only humans can understand it. Assembly level language, both humans and hardware can understand it. And object code can only be understood by hardware. Humans can't understand it because it's only bytes. Now the last step over here is a linker. Okay, what the linker tries to do is whatever the object code file was created, whatever the object code was created in the earlier step, it tries to link different library functions. For example, in our code we used cout and endl. So whatever code is required for these two functions only, that will be linked with our object code, and then an executable file is created. Okay, this is the ultimate step. This is equivalent to the a.out file which was created. Now this is implicitly created. If we wanted to create some other object code, we could tell the compiler that, okay, hey, create this create an executable file with this particular name. So let's try to do that. If I'm not wrong, -o is used to give that name. So when we are compiling, we can just let the compiler know that please use some other name. So over here, we want to use the name intro. So let's just compile it and let's look at the files that are created. So now as you can see, a.out already exists from the previous compilation and it has also created intro. So now if we try to execute intro, this also prints hello world. So in this way, you can give a name to your executable file if you wanted to, but a.out is by default. Okay, so a.out is default and -o and some name is used to give the name to an executable file. So this is how the entire process of compilation looks like, and we have also written our first program. So many congratulations to all those who have written the first program with this particular tutorial. If not, I would seriously recommend you to pause the video at this stage and write a program on your own, because watching a tutorial is one thing and converting the things that you are learning over here into real code is what is going to help you grow. Okay, so now let's take a look at some of the parts of a C++ program. Okay, I will just write this particular code which is there on the slide into our intro code itself. I will remove the hello world statement. Okay, now I don't need both of these as well. We will just have an int main program, and this is a comment int a. Don't worry what int a is. I will talk about that when we talk about variables. Now if you notice, this is a comment. So whatever is followed by // okay, this is // whatever is followed by that is a comment. It doesn't get executed by the machine. First of all, it is ignored completely whenever the compilation process happens. This is only for humans understanding. If we wanted to explain what a part of code is doing, then we can use comments to add that description over there. This is ignored. Both of these statements are ignored by our compiler. And this is a statement is also ignored by the compiler. Now over here, I'm using the statement, I'm using the comment over here to explain that whatever is covered in red on the screen, it is a statement. Okay, int a equals to 5, that is a statement. Now semicolon is the heart of a C++ program. Whatever code is mentioned before a semicolon, that forms a statement. So a statement is a building block. It's a fundamental unit of any C++ execution. So one statement is one step in a C++ program. Okay, so statement is a fundamental unit. Your code is broken down into multiple statements and all of the statements will get executed sequentially as they are mentioned. Now I have been holding you to understand what return 0 means. So over here we are returning an integer. This is what a return type means. We will cover that in much more detail in our topic about functions, but here return 0 means the program is getting executed successfully. If there is some other error, it will return 1 instead of 0, which means that there is some issue with your C++ program. Okay, so at this point, I think this is a good place to understand what the comments are, what the statements are, and what the white spaces are. Okay, so in C++ program, as if you remember previously, like we used cout and then we printed hello world and then we used endl. Okay, now what does endl do? It creates a new line. Okay, this can also be replaced by /n, which is an escape character. Okay, so instead of endl, you could have used the /n as well. So if you are looking at the screen right now, there is a /n instead of endl, and it will do the exact same thing. So that is a white space character. /n means add a new line after this. So let me just add the namespace which we removed earlier, and let me also include the header file for this. #include io, my bad, io stream. Okay, so now whatever is written between the parentheses, this is the name of the header. Okay, io stream, whatever comes between opening triangular brackets and closing triangular brackets, that is the header. And hash include tells the compiler to include this particular header. Okay, so now if I try to execute this again, let's just compile it. Okay, and let's execute it. It does the same thing. Okay, if it is /n or if it is endl, it has the same behavior. You can add a space in between as well. You can add tabs also in between. That's completely normal. Now if you look at the slides, there are some spaces involved in the demo code as well. In the example that I have provided, there is some space between int and a, between a and equal to, and between equal to and 5. So these two spaces are not required. You can get rid of them. But the space between int and a is required. It's because int is a keyword. Okay, it's reserved, and a is name of a variable. We'll cover both of these topics in a little detail. But over here, understand that the space between int and a is required because it tries to add a meaning. But if we were to replace int space a space equal to space 5 and a semicolon with int a equal to 5 with no space in between, it's completely all right. Okay, let me just make these changes in the code, and then I can show you what space is important and what space is not. So in the code, I have removed spaces before and after equal to, and let me not add any space here as well. So if you're looking at the code, I am breaking the entire code down into a single line. Okay, this will also get executed. You see, it has the same execution. So even if you were to add spaces or tabs, that's just for the human understanding. So if you can see on the screen right now, it is completely cluttered. Like I can't understand what the actual code is. So I will try to indent it. I will try to write all of the statements in different lines so that a human being can understand it. It is not an issue for the machine to compile it. It knows where the semicolons are. This means there is a statement. Where the forward slashes are, it means it's a comment, and so on. Okay, it understands everything, but for a human to understand, aesthetics are important to a code. Okay, so over here the tab is only for indentation. I could remove these tabs, get rid of the indentation, and then compile and run it. It would run as it was doing previously. But this tab helps me with the indentation and understanding of what part is in this particular main function's scope. So we have understood what the comments are, what the statements is, what is the importance of white space, where the white space is important, where it is not. And we have also written our first C++ program. So now let's move to what different data types are there in C++. So if you observed earlier, we have already used int data type, which is an integer. Okay, so those who are completely new with programming, let me just explain what bits and bytes are. So every program is, first of all, it's converted into zeros and ones. Okay. Now each of these values are stored in a bit. What a bit is, it means a bit can hold 0 or 1. This is a binary language. Okay. Now a group of bits is what a program is made of. So 8 bits is equivalent to 1 byte. Okay, this is not BITE byte, this is BYTE byte. This is different than the bytes we take while eating food. So 8 bits is 1 byte. So how much data can 1 byte hold? Okay, so 1 bit can hold 2 numbers, 0 or 1. And whenever I'm talking over here, this is the binary language I'm talking about. I'm not talking about the mathematics that we have pursued so far. So if I wanted to use 8 bits, then for each of the bits, I have an option to add 2 values, either 0 or 1. So 8 bits will hold 2 to the power 8 values, which is equivalent to 256 numbers. So 1 byte can hold up to 256 different values. So this is permutation and combination, normal mathematics, 11th and 12th standard, as far as I remember. So 1 byte can hold 256 different values. So if you look at char over here, so there is something known as ASCII code, which represents different types of characters you can add in a program. So an ASCII code has values from 0 to 255. So this has some special characters. This has alphabets, both capital, both small. It has digits, it has white spaces, and all the characters which you can use in a program. Okay, they are captured within this 256 values. So how much data is required to hold a character? It's equivalent to 1 byte. Okay, because 1 byte can hold 256 different values. So you can hold all the ASCII characters in 1 byte, and hence the data type for characters. If you wanted to represent some data for characters, only 1 byte is required. Now what is a boolean? A boolean means 0 or 1, true or false. Okay, true means 1. A boolean means true or false. And true is represented by 0 and false is represented by 1. So in theoretical sense, only 1 bit is sufficient to hold these values. But in reality, if you see one entire byte is allocated to it, it's because of the memory management in the modern systems that, like, theoretically, even though we can hold it in 1 bit, you would see that it occupies the entire byte. So all the 8 bits, it would look something like this. Okay, these are 7 zeros if I'm not wrong. Yeah. So this is how it would be represented. This is true and this is false. Okay, so one bool will, like, even though it requires only 1 bit, it will also hold 1 byte. Same as characters. Now there are a few other data types to hold the numerical values, that is int, long int, float and double. Int and long int are used to capture the whole numbers, negative numbers, 0 and positive numbers as well. And float and double are required for decimals. Okay, so let me just add that. This is for decimals. And int and long int are for whole numbers. Now there are a lot of other data types like short int, long int, unsigned integers as well. But for the scope of this particular module, let's not go deep into it, because these few data types are going to be sufficient to understand what different types of data types can exist. So as you can notice over here, int data type captures 4 bytes. Okay, this means that 4 bytes, which means 4 into 8, 32 bits are there. Okay, which means it can hold 2 to the power 32 values. All right, but integer doesn't hold just positive values. It also holds 0 and it also holds the negative values. So if you have a look at the range, it holds from minus 2 to the power 31 to 2 to the power 31 minus 1, including 0 in between. So in total, it holds 2 to the power 32 values along with negative, positive and 0. And similarly for long int, it is of 8 bytes length, which means 64 bits, and hence this range. Now for float and double, float is equivalent to integer in the sense that both of them hold 4 bytes each. Now, if you want normal, like, decimal capacity of 6 to 7 decimal digits, then float is sufficient. But if you want something very precise for scientific purposes, then you should use double, because it can hold up to 15 decimal points. Okay. So I think this part is sufficient to understand what all different primitive data types are. If it was, let me just explain in a little brief what unsigned means. Unsigned means there won't be any negative values. Okay, this will only hold positive integers. So if it was unsigned int, then it will store from 0 to 2 to the power 32 minus 1. Okay. So it won't store negative values, and hence it gives you more capacity for positive numbers. So if you were to use, for your use case, if you wanted only positive numbers, then you could have used unsigned int to get more capacity for more range. And same goes for long int as well. All right. So this is the place where we cover what different data types are. Okay. Now we move on to the next part where we talk about different variables. Okay. So what is a variable? A variable is something which holds some memory. Okay. If you remember, we used int a, right? So a over here is a variable name. Okay. Int shows what the data type is, as we talked about earlier. So this means that a holds 4 bytes in the memory. Okay, so whenever we create a statement like this, whenever this statement is executed, it tells the compiler that, hey, please allocate 4 bytes of memory to me, and the name of this particular memory would be A. In real, A doesn't exist, okay? It's just a label. Like my name is Aanshul. So Aanshul is just a label for me, but in reality, I'm just a human being. I just have some features of human being, like I have 2 eyes, 1 mouth, and so on. So similarly, an integer, like A is just an integer and A is the name of that particular entity. Okay. So this is what a variable would look like. Like instead of int, it could have been a long int. It would have more capacity. It would be holding 8 bytes instead. It could have been a boolean, a character, whatever we wanted. Okay. So over here, just to keep in mind, A is not an actual physical thing. It's just the name of memory which is allocated. So let's say in the background, there is some memory allocated, and each of this block is equivalent to 1 byte. So this in fact is 4 bytes. Now these 4 bytes are contiguous memories, okay? 1 byte, 1 byte, 1 byte, and 1 byte. All of these bytes are in contiguous addresses, and this entire 4 bytes are allocated to one integer. And the compiler knows that if we wanted to access it by using the name A, then it means we want to access the values which is held by this particular memory. Okay, we will talk about addresses and memory and all those in next module where we'll talk about pointers and addresses. But for the time being, let's just know this holds 4 bytes and A is just the name of the variable in order to access whatever is placed inside that address. Now this is what I actually talked about. Data type is int, variable name is A, and this is the value. So if you remember earlier, okay, we said that there will be some memory allocated to it. Now in that memory, we want to assign the value 5 to it. So if you had knowledge about what binary language looks like, then 5 is represented by 101 in binary language. Okay, binary language. Now you would be like, hey Anshul, this requires only 3 bits. Why are we storing it in 4 bytes? Okay, but this is how the nomenclature is. If we are representing it by int, it is going to store it in entire 32 bits or 4 bytes. So whatever things you cannot see over here, there are zeros in front of it. So there would actually be, these are 3 numbers. So there would be 29 zeros followed by these 3 bits. Okay, so this is how in memory it will look like. So there will be 5 zeros followed by 101, and all of these numbers would be 0. All of the previous bytes would be zeros. So this is how in memory 5 will be stored. Okay. So now just a bit of technical jargon, just a bit of technical nomenclature. So when you write int A, what the compiler does is it creates some memory. Okay, memory exists. Okay, it doesn't create memory, it allocates the memory. I should have chosen better words. So it allocates 4 bytes and tells that this 4 bytes belong to A. Okay, whenever we want to access A, we will try to find what value is stored inside those 4 bytes. So memory allocation happens here. All right, right now no value is assigned to it, so it will use the default value 0. So even though we have not mentioned anything in the memory, like let's say these are the 4 bytes, everything will be filled with zeros. Okay, all of these are zeros. So now we can initialize it by using this particular syntax. Variable name equals to value. This can be any value. Instead of 5, you can store 100. Okay, you can store 200. But now let's assume one thing. We know that integer holds 4 bytes. What if we tried to assign it to a value which was greater than 4 bytes? Okay, let's try to explore that part and let's see what happens. Let me just get rid of cout in the program. Let's get rid of the namespaces and the header files as well. Okay, so now instead of 5, if I were to add a very big value which an integer can't hold. Okay, so let's try to compile this program. What happens? Let's see what happens. So now we can see on the screen it shows me a warning that integer constant is too large for its type. Okay, this means that whatever number I added over here, it cannot fit in 4 bytes. And it also says overflow in conversion from long int. It means that a long int data type is sufficient for the number that I have mentioned over here. But since I have explicitly mentioned that this should be an integer, what it will do is it will convert this number into an integer. So it will be assigned to some garbage value. It will wrap it, like this is known as an overflow condition. First of all, whenever you assign it to a value which is larger than the capacity of that particular variable, it will lead to overflow. Okay, so just assume that instead of 32 bits in an integer, you, for example, added 60 bits. So there will be some part of this number which will flow out of the 4 bytes and will try to minimize it, restrict it to 32 bits. I don't know what logic is used behind it. Maybe it takes the last 32 bits, maybe it takes the first 32 bits, or maybe it does some processing and converts it into 32 bits. But what needs to be understood over here is that the code will not execute as you intended it to. So let us just try to print what the value of A is. Okay, so we will just try to print A and see what happens. Okay, so now let me add back the header files. If you notice, the header files and the namespace declarations were not required in the previous compilation. It was because int A equals to 5 and whatever zeros are there, it doesn't require any library or header file. Now I will not get rid of these two values because I need to add it again and again and remove it again and again. So let them be present even though we require it or not. So let's just try to execute this and see. If you notice, in the error, or in the warning actually, error is different from a warning. Error means your code can't execute. Okay, with errors you cannot execute your code. With a warning, it just gives you a sense that okay, your code might not perform as expected, so be mindful of that. So it says overflow in conversion from long int to int changes the value from whatever this value was, I'm not sure, to 0. Okay, this is how it's processing. Maybe it's converting to 0. Okay, let me just put a smaller number in this. I'm not sure if this fits into an integer or not. My hypothesis is it still doesn't. And over here it says that it overflows from an long int to an integer and changes the value from 5, whatever it was, to minus 743309312. Okay, so in this case it's not redefining it to 0, it's not assigning to 0, it's assigning it to some garbage value. So just a piece of advice that be cautious whenever such a situation happens and you know what the correct data type is. Let's say instead of int I were to use long int. Okay, let's see if this issue still exists or not. Okay, now it is not throwing any error, any warning, and let's hope it prints the same value. Yes, it does. Let me just compare it. I have copied it and okay. Now I pasted it. Yes, no extra digits are added to it, no unnecessary digits are removed from it. So both of the values were the exact same. So this is a blueprint of how database declarations happen. Now, as I was talking, some technical jargons over here. So let me just get rid of all of these values and let's discuss the technical jargons in a little bit. So now the technical jargon or the nomenclature here says that when int A is there, this is just a declaration. Okay, we are not assigning it any value. We are not defining what what A points to. Okay, so this is just a declaration, which means it will allocate some memory to it, but there is still no value in it. So by default, it will be 0. Now this is initialization. We are updating the value of A for the first time. So this is known as initialization. And if we were doing both of these things in the same statement, then it would have become a definition. It does both declaration as well as initialization. Okay, so I think this is sufficient to understand what the nomenclature is in C++ or programming. Now these are some rules for declaring a variable name. Okay, it should contain only letters which can be A to Z, and this includes both capitals and small alphabets. It can contain digits and it can also contain underscores. So now let me just try to create a variable with @ in between. So let's say if the name was a@. Okay, I'm not sure if this will compile or not. Okay, it says stray @ in the program. Let me just try to rename it to something else, and let's also use underscore in it. Let's see if it allows me to compile it or not. Okay, it says a was not declared in the scope because it's trying to access a variable which we have not declared. So let's just try to update it. Yes, it runs as expected. So this hypothesis is correct. Now it is case sensitive. So if there was something like AA and then AA with capitals, these two would be two different integers pointing to two different memories in your RAM. Okay, so both of them are different variables, so be mindful of that. Now it doesn't contain any white space or special characters. Okay, so this should not be there. Just make sure you understand what doesn't mean over here. We should not add any white space in between. We should also not have any special character. Must begin with an alphabet or an underscore. It cannot begin with a digit. Okay, so you can just try it out in your laptops. Try to name a variable starting with 0 to 9 anything, and it won't let you name it. Cannot use C++ keyword. So if you remember, I said int was a keyword. So there are some special names which are assigned for C++ keywords: int, long int, for, class, double float, all of these data types, all of these other special functions and so on. Those are reserved as for some different purpose. So you cannot use them for variable names. So these are some rules which you should keep in mind when you are naming your variable. Okay. So now let's move on to input and output operations. So we have already used it. Okay, first of all, we have already used cout. So in some sense, we are already aware what input and output operation means. But there are two types of streams, like there are more than two types of stream objects. There is also error stream object, but we are not going to talk about it. There are input stream objects which takes in some value from a device and it assigns it to a memory allocated inside the machine. Okay, so from device, the bytes flow into memory. Okay, this is input stream and we will use the cin keyword for that. Now what is an output stream? It flows the bytes from memory to device. Okay, and we will use cout keyword for this. Now if you are already coded in C previously, then you would know there are functions known as scanf and printf. Okay, so scanf is equivalent to cin in C++ and printf is equivalent to cout in C++. So we can use the same, like similar functions, like we can use cin to take an input and cout to take an output. So let's just try to take in input instead of assigning the value to A. Let me just rename it to A so that it's easier to read. Okay, so instead of assigning a value over here, let's just declare it. So in memory, some space will be allocated to it. And then instead of updating it, initializing it, let's take it from the input, from the user. Okay, add value for A. So let's try to just compile it and we will execute it. So now it printed add value for A. Now it has a cin command in the code. So it knows that it has to wait for a human output. Okay, so it will wait for my output. I have typed 3. And then as I press enter, it will try to read the value of 3 from the device, assign it in memory to the space which was allocated to A. And in the next statement, it will try to print the value of A. So as you can see on your screen, after I pressed enter, it executed rest of the code. The code was blocked until I gave it an input, and now it has printed the value of A. So this is how input-output operation happens in C++. And to the next part, let's talk about some of the operators. Now, you would know by definition in mathematics, there are operators like plus, minus, and so on. So operators work on operands. Okay, so there can be two operands if we are using a binary operator like plus, minus, multiplication, division, or modulo, it can have a single operand if it's a unary operator. We will talk about that as well. But these are unary operators which are suitable for only one operand. So when I talk A and B in the explanation over here, understand that those are two operands on which an operator is operating. And if there is some, let's say, this is not A. So when I talk just about A, it means I'm talking about a unary operator and unary operand. So arithmetic operations is quite explanatory. Like these are mathematical operations which take place between A and B. So there can be addition, subtraction, multiplication, division, and modulo. Okay, so I don't think I require to explain that in more detail. Now I will talk about assignment operators and unary operators after I explain the other ones. Now what are relational operators? Okay, now this is double equal to sign means it tries to compare two values. It tries to compare A and B and checks for its equivalence, checks for its equality. Okay, so now if A is 4 and B is 5, this will return false. Okay, so the output type of relational operators is a Boolean. Okay, and now I think this becomes, rest of all the operators become quite explanatory, that double equal means it checks for its equality. Not equal to, now explanation, the exclamatory mark, this is equivalent to not. So if we were to use not equal to instead, this would have been true. Okay, I'm not writing the code separately for this because I think you can try to explore it on your own. You can just pause the video at this place, try to write this statement. Okay, int A equals to 4, int B equals to 5, and then you can just try to print what is stored over here. A equal to B. So this will either print 0 or this will print false. I'm not sure what it will print, because 0 is equivalent to false, so it is possible it might print 0 as well. So you can just try to execute this code and see for yourself what the outputs are. Now this is the greater than symbol, greater than equal to, less than, and less than equal to. We have been using this relational operators for a very long time, so I don't need to explain all of these again. Now logical operators require the operands to be Boolean values. Okay, so now this double ampersand operator means AND. So if both of them are true, then only the value of this will be true. If any one of them are false, then it will return false. So at this point, I am assuming that you are aware about how AND and OR and all those logical operators work. I am just here to explain what is the equivalent operator which we can use in C++ language. Now over here you can see a NOT operator as well. Now this is a unary operator. So if I were to mention NOT A equal to B. Okay. So first of all, it will try to resolve A equal to B. This is equivalent to false. And when we will expand NOT, this will mean negation of whatever the Boolean was there. So NOT is also meant, the operand for NOT should be a Boolean value. So it will try to reverse whatever Boolean was there. If it was false, it will turn it to true. If it was true, it will turn it to false. Okay. So this closes logical operators. And now talking about the bitwise operators. Bitwise operators are applicable on the bits. Let's say this was 101, which is equivalent to 5. Now this is in binary language. So now if I were to use B and this bitwise operator followed by a 1, this means that this binary value should be shifted by one place. Okay, we will add 1 0 after it. All right, so this will convert 5 into 10. So basically this operator will multiply the operand by 2, and if we were to use the other operator, it will try to divide its value by 2. So if 101 was there, this operator will convert it into 10. The 1 is shifted to the right and we get rid of it and only 10 remains. So 5 divided by 2, its value is 2. Okay, it doesn't convert it into a decimal value. It will try to seal it. Okay, so this moves the bits by one place. Like if the other operand was 1, If instead we were, let me just remove the other stuff so that it's easier to understand. So now B, so if this was our expression, it would mean that 101 should be moved by, if I'm not wrong, A was having 4 and B was having 5. This should move 101 by 4 places. So our output for this would be 5 followed by 4 places, which is equivalent to 5 into 2 into 2 into 2 into 2. This is 5 into 16, which is equivalent to 80. So a new value will be 80. This is equivalent to 80. So now you might be confused what single ampersand, pipe and caret means. So single ampersand is also equivalent to double ampersand. But double ampersand, the operator operates on Boolean values. A single ampersand operates on bits. Okay. So if it was 0 and 1, this will mean like AND means both the operators should be equivalent to 1. Both the bits should be 1. In this case only it will return a 1. In all the other cases, 0 and 1, 1 and 0, 0 and 0, it will return the bit 0. Okay. Now, just to keep in mind, I will reiterate this again. The inputs are bits and the outputs are also bits. In logical operators, the inputs are booleans and the outputs are also booleans. Though we can represent booleans by bits and bits by booleans, let's not try to replace these operators in the actual code. If the operators operands are meant to be bits, then let's use bitwise operators. If the operands are meant to be booleans, then let's use the logical operators only. Now OR is also explanatory because we used it earlier in logical operators. Now this caret means XOR. Okay. Now XOR means if the parity of both the bits is same, let's say it was 0 XOR 0 and 1 XOR 1, it would return the bit 1. If the parity was something different, like 1 and 0, both of them are a different parity, it will return a 0. Okay, so bitwise operators is also done. Now let me just remove all of these details again. Let's talk about the assignment operator. So assignment operator, as explanatory, like the equal to sign, assigns one variable some value. Okay, so if we had to do A equal to B, so what it will do is it will update the value from 4 to B. So now before it was holding value 4 and now it is holding the value 5. So in this way we can update it to any value. This could have been A equal to 6 as well. This would also update it. It would assign the value. Now what does plus equal to mean? If I were to use plus equal to 5, this is expanded to A is equal to A plus 5. What it does is whatever the right operand is, it adds that value to the left operand. Okay, but we cannot do, obviously we cannot do 1 plus equal to 5. Okay, this means we are indirectly saying 1 is equal to 1 plus 5, which is a mathematical fallacy. Okay, so instead let's remember that in assignment operators, the left hand side, which is the LHS, it should always be some variable. Okay, now all of these, like over here we used A plus equal to 5. Now this plus can be replaced by any of the arithmetic operators. Okay, any of the arithmetic operators or any of the bitwise operators and so on. Okay, let's not replace them by logical operators and relational operators because they are meant for booleans. Okay, like the output of relational operators is boolean and the input of logical operators is boolean. So we will use arithmetic operators and bitwise operators in assignment operators as well. We can use them. Okay, so we are done with assignment operators and now talking about unary operators. Now what does A plus plus mean? A plus plus means we will add the value, increment the value of A, which means that if A was 5 earlier, now A would be 6. Okay. Now this plus plus can exist before A as well and after A as well. So now if, for example, let us try to take a complicated example. If I were to do A is equal to B plus plus. Okay. So what it indirectly means is that first we will try to assign the value of A to B and then we will update the value of B. If instead of B plus plus, it was A equals to plus plus B, what it does is it will first increment the value of B, which means that it will increment the value of B to 6 from 5. Earlier it was 5. it increments it to 6, and then it will assign that incremented value to A. Okay, so plus plus before the variable name means that before we use it somewhere, the value of B will be incremented, and same goes for minus minus, it tries to decrement it. And if the plus plus, if the unary operator is followed by the variable name, it will first assign that value to A, and then it will be followed by the increment. So this is what unary operators do. Now I think we have talked about a lot of operators in detail, so you should be good to go for a lot of operations. You can just take in input A and B and then print the summation or subtraction of A and B, and you can try out various cool things now. Okay, so now coming to the last part of this first module, which is decision making. So now here we come to the first part of a C++ program where we will try to do something cool. Okay, A plus B is cool enough, but let's try to do something cooler. For example, like whenever you are going out, whenever I go out in Bangalore, I check the weather. Okay, if weather is cloudy, or it is raining, take umbrella. Okay. So when will I take an umbrella? It would only be when the weather is cloudy or it is actually raining. If that condition is not true, then I won't take my umbrella out with me. Okay. So there are lots of decisions that we make in any program. It can be a C++ program, Java, Python, SQL, or anything at all. We will be making some decisions, and to make those decisions, we are going to use conditional statements. So in C++, there are conditional statements, like these are keywords. If, else, both of them are keywords. If and else, these are keywords. Okay, so these are reserved. We cannot name variables by these keywords. So this is equivalent to the human language. Like this is equivalent to the English language that we use. If followed by some condition. Okay, now this condition should result in some Boolean value. Okay, it can be A greater than 5, or it can be A and B. In this case, both of them needs to be Boolean, A and B. Anything at all, the output should be something Boolean. Okay, if condition, then we will try to use the braces. We will try to do something. Okay, we can execute any part of the code, whatever we wanted to do, followed by that condition. So we can do something, we can execute some part of code. Okay, it can be if A greater than 5, then update the value of A by 10. I don't know. Okay, I'm just writing something. And if the code is like this, like there is a single if statement, then it will enter the block. Okay, this is known as a code block. Whatever is between the curly braces, the opening braces and the closing braces, if anything is there, that piece of code will get executed, that block of code will get executed. If that condition is not successful, then that code block will not get executed. Whatever is there above this code block and whatever is there below this code block will get executed. It will enter this code block only on the success of this condition. Only if this is true, then this will get executed, otherwise not. So now let's just try to write some code for this. Okay, let's not take the value of A from the user. Let me just define it to 5. We can use an integer instead of long int. So let's just add a statement. If A is greater than 3, then we will print greater than 3. Okay, I'm just writing something for explanation. Or now there is no else part to it. Okay, it is not this or that. In this case, it will just try to execute the next statements because we are not writing any else syntax over here. So in this case, we'll just change the output to normal execution. Okay, so let's just try to compile it very quickly and execute it. So since A is equal to 5, it also prints greater than 3. It will print normal execution in any case. Let's just try to change the value of A from 5 to 2. In this case, this command fails, A greater than 3 fails. It will be equivalent to false. So in case of a false condition, it will not try to execute anything which is within the if block. Okay, so let's just try to quickly compile it and then we will print it. So as you can see, it doesn't print the greater than 3 statement. It will only print normal execution. Okay, so now let me also add else part. Okay, so in this case, it becomes this or that. If a is greater than 3, then do this, else do that. Okay, it has to do one of the two things because a condition can either be true or false. So in case of true, it will execute the if block. In case of false, it will execute the else block. So we'll just write less than 3. Okay, so let's compile it again and run it. It prints less than 3 and normal execution. Now let's just once again, for my satisfaction, let's just try to update the value to 4 and then run it again. It prints greater than 3. So in any of the cases, it's going to print something. Okay. So if you check over here in the slides, it says if the condition is true, it will execute this. And okay, I did a typo. If the condition is true, then do something. And if the condition is false, okay, whatever this condition was, if it is false, then execute the other part. Whatever is followed in the parenthesis, whatever is between the parentheses after the else block. Okay, but now here there can be multiple conditions as well. For example, if a is greater than 5, then do something. In this, we can have nested if and else as well. Okay, but there can be a chain of conditions as well. It can be else if, we can use else if instead. Now, if a is greater than 5, do that. Then let's use another condition. Else if a less than 3, do something else. Okay, not so good drawing. All right. So now if a is less than 3, it will execute this code block. Okay, whatever the condition is, if it is true, then it will execute this code block. If the first condition is true, it will execute the first code block. Okay, if the second condition is true, it will execute the second code block. But now if I were to change it, okay, let's say if I changed it to, oh my bad, if I changed it to a greater than 8, okay, now let's say if the number of, like if the value of a is equivalent to 9, okay, it will succeed the first condition. Okay, which means the first block will get executed and it will never move to the second block. The else if part will completely be ignored, because else means if it is not greater than 5. But in this case, it is greater than 5. So it will not even consider this second if block at all. So you should be very cautious how you are defining the conditions. If you wanted to cover the a equal to a greater than 8 part, then it should have been within the first block itself. So let me just try to cover that thing in our code. A greater than 5. So we will print greater than 3. And we will also add another condition for a greater than 8. Okay. If you notice over here, the white spaces are not important before and after the operators. We can just print greater than 8. Okay. So now let's just keep it equal to 6. So in this case, so just to show you, so there are 3 code blocks in this case. If a is greater than 5, there is some code block. Inside it, we are trying to add another code block for a is equal greater than 8. So this is code block 1, this is code block 2. And after that, we are also having a else statement. So this will be code block 3. So when will 1 be executed? 1 will be executed anytime when a is greater than 5. 2 will only be executed if it enters the first block, which is on a greater than 5, and also if it is greater than 8. So let's say if it was some number like 9, 10, 11 and so on, it would have executed both first block and the second block, and the third block would have been ignored. So let's just try to execute this thing. A is equal to 6. In this case, it will not enter the second block because when we try to compare it with a greater than 8, it will fail because 6 is not greater than 8. This will lead to a false and we will not enter the second block. So let's try to just run the program quickly. You can see it executes the statement in the first block but not in the second block, and it ignores the third block altogether. Now if I update the value from 6 to 9, it should execute both of the statements in the block 1 and in the block 2. So yes, it does as we told, it executes both of them. So in this case, you can add any number of nested conditions. There can be any if-else statements inside the if part. There can be any if-else statements inside the else part as well. Okay, so for example, we will enter else block only when a is less than equal to 5. Okay, so we can update the statements inside 3 to do something. Okay, let's look at the code. So now if, okay, first of all, I had to change the values. This should have been equal, greater than 5, greater than 8 is right, and this should have been less than 5. Okay, so inside else also we can add other conditions. All right, so if a equal to 5, then print equal to 5. Okay, now this actually should have been less than or equal to, because this has both those conditions. A can be equal to 5 or it can be less than it as well. So now let's try to execute it when the value of a is equal to 5. So now there are 4 blocks actually. Inside the third block, there is another 4th block which checks for the equality of a with 5. So now if I have a equal to 5, it will first of all, the first condition will fail. It will not enter block 1. Then it will check for, like, obviously, like if the first condition fails, it will go into the else part. Okay, so it will enter the third block and it will check for the condition over the 4th block, and we will try to compare it with 5. So let's quickly try to run the program. It says it first enters the block 3, which has a statement less than or equal to 5, and then it checks the condition over the block 4 and it compares it with 5. It is again true, so it will enter the block 4 as well and it will execute equal to 5, and then the normal execution happens as it is outside the if and else block. So this is how you can add any number of nested if, else, else if conditions inside it. Okay. So now there is another type of a control statement, which is switch. Okay, switch is a keyword. So inside this there can be an expression, and this expression should not be constant. I mean, it can be constant, but then there would be no purpose of using it. So switch a. Now there is a condition, like there are some rules to be followed in switch statements. First of all, whatever the expression is inside, it should either be an integer or a character. Okay. So now over here in this case, a is an integer, so we are fine with it. Now whatever the cases are, okay, now case is also a keyword. Okay, it will try to match with value 1. If that is true, then it will try to execute the statements which are inside this block followed by value 1. If it tries to match all the values, it will try to match with value 1, it will try to match with value 2. If there are other values, it will try to match it with them, and then it will execute that particular block only. So if you were to build a calculator, you can use a character instead of an integer, and then in the values you can have case followed by a character. Okay, this can be a plus, and then you can have statement like do a plus b or something like that, return a plus b or do a plus b. And then the break statement over here says ignore whatever is followed by this. Break means get out of the switch condition. Okay. If there was no break statement, it would have tried to match with other values in the future as well. Like whatever values are followed by value 1, it will try to match it with them. Whenever it encounters a break statement, it will try to get out of that block. So this block is switch block, it will try to get out of it. Okay. So I'm not writing the code for this, but I really want you to pause at this stage and try to implement a calculator. You can take in two values a and b, and you can also take an operator in the form of a character. Okay. Declare a variable c, and then if it is addition inside this statements, you can try to update the value of c to a plus b. Now if this was subtraction, you can update the value of c to a minus b and so on. And then after this switch block, just print the value of c. Okay, this will be your first mini project of a sort where you try to implement a calculator. Okay, Now let's take a look at the rules, because switch is a very tricky conditional provision in C++. The case value must be either integer or character. There are any number of cases. There can be any number of cases. Okay. So this is a case. This is another case. There can be any number of cases. No duplicate case values are allowed. Okay. For example, if I had value 1 equal to, let's say, plus sign, I cannot have the same, like value 2 cannot, or value 2, value 3, 4, 5, any number of values are there after 1. It cannot have the same value associated with it. Okay. Each statement of case can have a break statement. It is optional. If we don't have a break statement, then it will try to continue comparing it with value 2 until it matches that particular value, goes inside that block, and there is a break value again. Okay. If there is a break value, it will get rid of it. Otherwise, it will keep entering the other values. Now, default statement is also optional. What does the default statement do? Let's say plus, minus, divide, and multiply. We have added the case statements for each of them. Okay, case values have been added for each of them. Now, if someone adds some jargon, okay, like @ sign, okay, that is very much possible in whenever you're taking in input as a operator, whenever you're taking the input from a user, they can behave in any unexpected way. You wanted them to use it as a calculator, but they just wanted to mess with you. Okay, so they can add in any character. It can be Q, W, any character at all. So they can be put into the default statement, and you can just print, hey, can you please add only one of these particular operators, plus, minus, multiply, divide, or modulo if you want to. Okay. And those statements can be a part of the default. So if any of the above case values are not true, if any of the above case blocks are not entered, then it will enter the default block if it is present. If it is not present, it will just get out of the switch block and nothing will get executed. But if the default statement is there, then it will enter the default statement whatsoever it is, and then it will get rid of it ultimately. So these are some of the rules of switch conditional provision by C++. Like switch statement has all of these provisions, and you need to be very mindful of these rules, because an addition of a break statement, a misinterpretation, okay, let's say you forgot to write a break where you actually had to, so it will try to keep on continuing the execution and comparing it with value 2, value 3, value 4, and so on. So make sure wherever break needs to be added, you need to add a break. Wherever you actually want break to not exist, it is completely fine. Okay. Inside a case block, there can be if and else condition if you want to. There can be a nested switch condition as well. That's completely fine as well. So it is just a piece of code, like inside the case value statement, it's just a piece of code. It can have anything and everything. So I feel we are at a good place to take a break for this module 1. What did we cover? We covered a lot of things, like we talked about data types. Okay. We talked about data types. We talked about C++ as a programming language. We talked about programming. We talked about variables. We talked about operators. And now we are closing on the conditional statements. So now what I would want you to is revise all of these things that we learned in this first module, and then we will meet next time in another module where we'll continue with other things about C++, which is there are different types of loops, for loop, while loop, do while loop, and so on. Then there are functions, then there are arrays, strings, and we also have pointers and all of those things. So I don't want to overwhelm you with what all we are going to cover in the next module, but I really want you to have a recap of all of these topics and try to implement it on your own. So if you found this content insightful, do give it a thumbs up and add in the comments if you have any doubts. And if you want to keep receiving such insightful content, don't forget to subscribe to Scalar's YouTube channel, and don't forget to hit the bell icon so you never miss out on such important notifications. See you in the next module. The last time we met in the first module, what did we discuss? We talked about the different data types in C++, how the variables are declared and initialized, what all different operators are there, and then we paused at the conditional statements, which are the if-else conditions and the switch conditions. Now let's take it a notch higher and let's start talking about loops. To the beginners, it might be confusing what loops are, but those who have already understood some of the other programming languages, maybe JavaScript, maybe Java or Python, they know what loops are. But to those who are beginning with C++ as their first programming language, let me just explain what loops are, okay? For example, someone asks you, okay, in the school, I usually used to get this punishment when I used to irritate my teachers a lot, that they used to write in the notebook for 100 times that you will not interrupt the teacher in between the class, okay? And she used to tell me that write this down in your notebook for 100 times. So in programming, obviously you don't need to write out, see out, something, okay, I keep making this mistake with the operator. 1 second. Okay, yeah. So you don't need to write sorry. Let's say the mistake was supposed to be rectified by just saying sorry. Okay. So you don't need to write this particular statement 100 times. For operations where you want to keep on doing a similar kind of a thing for some n number of times, okay, for some number of times, you can use loops. What loops basically mean? There will be a code block. You will start with a code block. You will end at the code block and you will keep on repeating until some condition is getting fulfilled. Okay, so now there are 3 types of primary loops in C++ programming language. So first one being a while loop. We will talk about the syntax of all of these different types of loops and how you can actually code it. Like we will write the code for that as well. Then a different flavor of while loop is a do while loop. Like I will tell you the difference between both the while loops, like in what situation what should be used. And lastly, there's the for loop. For loop is one of the most basic loops which people usually use in C++. And why it is more widely used as compared to while loops, that I will also let you know. And similar to the if and else statement, there can be nested loops as well. Inside a for loop, there can be a while loop. Inside a while loop, there can be a for loop, and anything can happen. Like any permutation combination is possible. But the first thing to remember is, let's say this is a for code block. Okay, this is a code block, and inside a code block, any type of code can be written. There can be an if and else condition, there can be a switch statement, there can be another loop, there can be any other type of code block as well in this. Okay. So let's move on to understanding the syntax of while loop first. So this is one of the most basic loops with least amount of syntax. Okay. So as you can see on the screen, like the syntax looks like while, and this is a keyword. Okay. You cannot use it for variable names. This is a reserved word in C++. While some condition, if you remember in if and else if statements also, we use some type of a condition. So while this condition is fulfilled, we need to execute a code block. Okay, as simple as that. So for example, let's say we have int a is equal to 5. We will keep on continuing with that previous a b example. So let's say int a is equal to 5. Okay, and the condition was like while a equal to 5. For example, do something. Okay, I don't know, it can be any piece of code. You can do some arithmetic operations, you can print something, you can multiply something, you can add an if and else condition inside this as well. But as long as this condition is true, the code block will keep on repeating itself. Okay, now you might be wondering, I mean, if a in our statement a is equal to 5, and while a equal to 5, we want to keep running the same code block again and again on a loop. So will it not become an infinite loop? You are absolutely right. You need to be very, very cautious about such infinite loops, that your while loop should always have an update statement. Okay, if your condition is using a as a variable or b as a variable, okay, if there are any variables involved in your condition for the while loop, there should be an update statement wherein maybe you are adding something to a. Okay, let's say you are adding a, incrementing a. So as soon as that condition is violated, you will go outside the while loop, you will exit the while loop. Okay, but this was not one of the best examples that I gave. So let's say I want to print hello world for 5 times. Okay, let's move on to code and see how we are going to write it. So in the code also, we stopped in the if and else nested conditions. So let me just get rid of all of that code, and we can write the code for while loops directly. Okay, so what we can do, while, now here we have a equal to 5. Okay, so this helps me keep a count of how many times I actually want the loop to be executed. So what I can say is while a greater than 0, cout hello world and followed by a new line. Okay, but now if I execute the code as it is, okay, it will keep on running for an endless time. Let's try to execute that as well and show you that how our expected behavior is not intended over here. And this is a very common mistake, to be very honest. If someone writes an infinite loop, you will see it a lot of times that people forget to update the variables in their conditions in order to get the expected return. Okay, let's compile the code. Let's try to execute it. Now you can see this is running endlessly. Okay, I had to press Ctrl C to interrupt the program. Otherwise it would have run endlessly until perhaps this laptop crashes. Okay, so we don't want such a situation to happen because this is not intended. What we wanted was, I wanted to print hello world for 5 times. So what I will do is I will reduce a by 1 in every loop. So in the first loop the value of a is 5. In the second loop it will be 4. Okay, let me just write it in the slides. So loop 1, the value of a is 5. Loop 2 it is 4. Loop 3 it is 3. Loop 4 it is 2. In loop 5 it is 1. Okay, so when we enter the loop for the first time it is 4. So when we will be entering the loop for the 5th time it will be equal to 1. Now when we enter the loop for the 6th time, we have decremented it at the end of the loop, if you notice. Okay, so when we will try to enter the loop for the 6th time, the value is 0. And each time we are going to check for the condition that is a greater than 0. If yes, then only we will move. So for all of these time that condition was true. Okay, true, true, true for all the first 5 loops. Now as soon as our value is updated to 0, a's value is updated to 0 now, and we try to check the same condition again, this time the condition returns false, and hence we will no longer continue with our while loop and we will exit from it. Okay, now let me just print something at the end of our program just so that we know that the program executed normally. Normal execution. Okay, so now let's try to compile it and let's see if our expected behavior is seen here or not. If I count properly, these are 5 times. Yes, hello world is printed for 5 times, and then after it exits from the while loop, it is printing normal execution. So this is what we had expected. So while loop is as simple as it looks. Okay, but people usually make this mistake that they go into an infinite loop or they don't write the condition properly. Okay, for example, if you write while loop something like this, while true, okay, and then there is a code block. Now this condition will be true forever. Okay, this is not going to change. Instead of true, there can be while anything. Okay, this is an interesting thing. I should have told this earlier as well. Let me remove all the other jargon so that I can explain this very properly. Now, when I told you in the if, else if and the while loops, we need to put in some sort of a condition. Okay, while loop, we are putting in some condition, and the code block will be followed only if the condition is true. And same was the case for if and else if conditions as well. But now there are some special type of conditions which are implicitly converted to booleans. For example, if we write while true, okay, now this itself is a boolean. I mean, this is an explicit boolean, which means that it is always going to be true because it's a constant. Okay, if we wrote here instead of while true, this was while false, this would mean that the condition is always false. So it would never enter the while loop at all. Okay. Now if I wrote while 1 or anything, okay, any non-zero number, while any non-zero number, any positive number, if I wrote over here, this would also be equivalent to true. Okay, this might not sound so obvious to you, but there are some implicit conversions within C++ wherein an integer can be converted to a boolean. Okay, so now, for example, okay, let me just update the code. You can check in the code what I actually mean. Okay, now in the 7th line, I explicitly write the condition while a greater than 0. But if I remove greater than 0 and if I just keep while a, it will still do the same execution, because as soon as the value of a becomes 0, it converts from true to false, because 0 is mapped to false and all the positive numbers are mapped to true. Okay, so whenever it was 5, 4, 3, 2 and 1, it would implicitly be converted to true. All right. So let's just compile the code again and try to execute it. And this is the same output that we are getting for this changed code as well. Okay, so these are some implicit conversions which you should keep in mind. Like, you can try to reduce the amount of code with such conversions, but for the readability purpose, I would really recommend if you write if a greater than 0, while a greater than 0 only, because then it is easier for the human beings to understand it. Okay, the computer knows, the compiler knows that a and both of these statements, okay, while a is same as while a greater than 0. Okay, both of these mean the same thing over here, but like compiler understands both of those things equally. But for a human being, this is easier to understand because it explicitly tells us that a is an integer and we are comparing it with 0. Okay, so this is just about good coding practices. This is nothing about C++ as a programming language, that you should be as explicit in your intentions as possible. Though both of them are theoretically true, both of them are theoretically same, we should not do that. Now let's talk about do while condition. Okay, now over here one thing is also to be understood, that our code block will only be executed if the condition is true from the very beginning. Now do while loop does something opposite to what while loop does. Now there is before the condition is checked, there is a code block. And like in normal English language also, it's like do, like there can be something over here, there can be some code block, and then check or keep on doing this while some condition is true. Okay, and remember there is a semicolon at the end here which was not there in the while loop. Okay, so now these are two of the significant changes. A semicolon is there at the end of this while condition statement, and a do while loop will always be executed once. Okay, at least once. My bad. Again, poor choice of words. So this will always be, my bad, yeah, be executed at least once. Okay, so when I translate it into English language, it will be like do something, check for the condition, do something, check for the condition. And once when we check for the condition, if that condition comes out to be false, only then we break out of this do while loop. Okay, so now let me try to change the code and let's try to use do while loop instead of a while loop. So this condition will come at the end. So let me just copy paste it to the end and write do in the beginning. So if you notice, this code will also execute for the same number of times, but there is a catch in this. So if you notice, this is the same execution which was previously, but let's say now we update the value. When we initialize it, we update the value of a to be 0 instead of 5. So what will happen is, even though our condition is not getting fulfilled, the do block is before the conditional block, and hence our code will get executed for one time in this situation. So if you notice, hello world is getting printed even though the condition is false. But in the do while loop, this is the classic reason why do while loop can be preferred compared to a while loop. It's because you want to execute the loop at least one time. Okay, so in those situations you can use a do while loop. Otherwise, while loop is like after for loop. I would say in my experience, while loop is one of the most common loops in any programming language. So this was the difference between while loop and do while loop. And obviously in this also remember to update any variable that you are using in your code block. Okay, so in your condition. So if you are using a greater than 0, or if you are using a greater than b, or any other condition that you are checking. Okay, if you're checking for a and b or anything at all. All right, make sure that there is some update in your code block so that there is a possibility for the condition to break and we exit the while loop. Otherwise, an infinite while loop or a do while loop is very much a possibility if we don't take care of these things while coding. And it is easy to ignore. Okay, I mean, I must have written a while loop for n number of times. I don't even remember them in my career. And that is the reason why for loop should be used so that we don't forget the update part. So So now this is the major difference between a while or do while loop as compared to a for loop. So this is what the syntax looks like. The for loop, like in while loop, there was just one condition. In for loop, there are three parts. The first one being the initialization. The first part is initialization. The second part is condition, which is common as while loop and do while loop. And the third one is update statement. Okay. And now, see, the condition needs to be only one. Like it can be a true or false related condition. The initialization, it can be any number of initializations that we want to do. It can be one, it can be more than one, it can even be zero. Okay, you can initialize outside the for loop. That is completely fine as well. Update also, it can be 0 or 1 or 2 or any number of updates. All right. So this can be 0 or more. This needs to be exactly 1. You can add more conditions by having more logical operators like and, or, and so on. Okay, you can use these operators to combine conditions. You can use or as well to combine the conditions. That is completely possible. But ultimately, the condition should end up in some Boolean value. Okay, so now updates can also be 0 or more. So if I were to classically convert the current code, okay, instead of a do while loop, let's say it was a while loop. Okay, let me just retrace it back to the while loop. A is greater than 0 and we'll get rid of this. So now this is the while loop that we wrote. Now if I wanted to write an equivalent for loop for this, I can write something like this. Okay. Now first part should be my initialization, but here a equal to 0. Okay, now this should also be equal to 5, otherwise it would never have entered. Okay, so a equal to 5. So now it has already been initialized. If you want to re-initialize it or update it to some other value, you can do it over here, or you can keep it empty. Okay, you can put a semicolon and not write anything in front of it to show an empty initialization. You can add the condition same as the one in while loop, and you can also keep the updates empty. Okay, let's copy paste the same code. So you can add the updates inside the code block of a for loop, or you can add the updates in the syntax of for loop itself. Both of them are equivalent. So let me just comment this thing. I think this is for the first time we are using the comment feature in C++. So let me just comment it and try to execute the for loop. This will execute in the exact same way as the while loop. Okay. Now we want to understand what is the beauty of the for loops, why one would prefer it as compared to a while loop. So let me just comment a equal to 5 as well. And over here, I can initialize it on my own with the for loop syntax itself, and I will decrement, provide the updates here as well. Okay. Now let's try to, if you notice, I removed the update statement from the lowermost part of my for loop, and let's try to execute it again. So now if you notice, this for loop is completely equivalent to the while loop that we wrote. We don't have any explicit update statement at the end of the for loop. We don't have any explicit initialization above the for loop as well, like outside the for loop on top of it. We have combined all of that together, and this helps in the brevity of code. Okay, both of them are the same thing. The compiler has the same interpretation of both the codes. So when it's converted into assembly language, if you notice, the compiler converted the normal source code to assembly level code. So whenever it's converted to the assembly level code, it would mean the same thing. The hardware level instructions for both the while loop that we wrote earlier and the for loop that we are writing right now, it would be the same. So let us check how we can add multiple conditions as well. Like this can be b++, and we can have another condition a equal to b. Now sometimes I have seen this common mistake, okay, that sometimes people, instead of putting double equal to sign, they put a single equal to, and a equal to b is an assignment. Okay, it will always return 1. This doesn't return a boolean first of all, and since it is an assignment, it always will be equal to true. So this condition will never fail. Let us just try to do that as well. And now let me also initialize int b equal to 0. Okay. So now in every for loop, what will be done? A will be decremented from 5 and b will be incremented. Both of these things will happen at the end of the loop. So initially we start with 5 and 0. This is the value of a and this is the value of b. Okay. And this in the first loop, we will enter the loop with these values. In the second loop, we will decrement a and increment b. In the third loop, we will decrement it to 3 and increment it to 2. In the fourth loop, if you notice, we are decrementing it and incrementing b. And now in this process, a and b will never be equal. Okay, you wanted the for loop to be executed till a. Well, first of all, okay, let me take it step by step. Let's first try to see what a equal to b returns. Okay, so my hypothesis over here is that it will always lead to true condition and it will always be executed. So there is a compilation error. So expected unqualified ID before int. I'm not sure what it exactly means over here. Expected semicolon before int. So it says that I should be using a semicolon before int because it's a statement. Okay, did I do something wrong in the code? Apparently, okay. I think this is the equivalent statement. This is what I wanted to do and this should compile, right? Okay, now I try to execute it. First of all, it doesn't enter the loop at all. I think, let me just try with another example where the values of a and b, both of them are equal. Then we'll do some of the changes and then try to see what's the expected behavior. This is also not entering. So my guess is let's try to print the value of a equal to b. Okay. Let us try to print. Let us first initialize both of them. So in this way, you can initialize both of them in the same statement. Okay. You can just separate them by using commas and you can initialize both of them in the same statement. You don't need to write int a is equal to 0, int b is equal to 0 in separate statements. Now let us try to print this. Let me just put some marker, something. Okay. My creativity has ended over here. So I'm just printing something over there. So after something, if you notice, it is printing the value of a equal to b, which is 0. So what I said earlier, that whenever we do some sort of an assignment, this is equivalent to true. I think I said the other way around. This is always equivalent to false. So you were expecting the for loop to be executed, but since you missed out on one equal to sign, it translates it to some Boolean value, which is always false, and it never enters the for loop at all. Okay. So now let me just change the condition and let me put the appropriate initializations over here. So first of all, let's just not get rid of the initialization that we have done outside the for loop. We can update them as well inside the for loop. Like if we want to have some different starting values of a and b, we can do that in the initialization part. So initially I just declared it, and hence on the declaration, it will automatically assign it to the default value 0. Both of them will have a 0 value, but in the for loop, I am placing an initialization statement that a should be updated to 6, b should be updated to 0, and then we should start it. Okay. So now I have updated it to 6 because I noticed for the value of 5, it was never matching each other. Like both of them were always different. Okay. So I wanted the sum of a and b to be even numbers so that when we decrement one and increment the other, we have a matching condition. So if you notice, hello world is printed 3 times. Okay. So now in the first loop, it will be equal to 6, a will be equal to 6, b will be equal to 0. In the second loop, I think it's only a's value which is getting changed. 4 and 3. So if you notice in the fourth loop, at the end of the third loop, a will be decremented from 4 to 3 and b will be incremented from 2 to 3. So at the end of the third loop, both the values match, and in the beginning of the fourth loop, we check for that condition. Is a not equal to b? So when you check for this condition, okay, 3 not equal to 3, this will return false and we will exit the loop. And hence, our hello world statement is printed only 3 times. So this is the basic way, like this is the most usual way in which we can use a for loop. Updates and initializations are optional. You can place initializations on top of the for loop. You can place updates inside the code block of for loop as well. But it is recommended that since, for loop is given for this specific purpose, that you can put all of them in the same statement. So you should try to adhere to that particular statement as much as possible. Okay. Inside the for loop, you can place some if and else conditions. If you want to place another for loop, that is also completely normal. If you want to, this is a code block, and this code block can be anything. It can be if and else statement. You can initialize something inside the for loop as well. You can update the value of any pre-initialized value, okay, pre-initialized variable. You can do anything which is equivalent to a statement. It can contain 0 or more statements. It can be an empty for block as well. If it is an empty for block, it won't do anything at all. All right. So I want you to just try and experiment around with all these 3 different types of loop and check out for yourself how, what works and what not works in all of these 3 different types of loops. Now, from the for loops, let us move on to the non-primitive data types. Okay, arrays is the first non-primitive, first non-trivial part of our C++ module. This is non-trivial. And what are arrays? Okay, this should be the first question if you are starting programming for the first time. Now, let's say there is a use case wherein there is a class of 100 students and you want to store the marks of each of those 100 students. Now, how will you do that? One of the way would be int Aanshul marks. Okay. And similarly, we can have such 100 variable declarations for all the students, possibly Raj marks. There can be some other names as well, but in this way, you would have to do 100 initializations and you would have to do 100 such updates or anything that you want to do with all of these marks. Let's say you wanted to calculate the average marks of the class. Okay, you would need to write each of these variables separately, add them up, then divide it by 100 and then get the average. So why is arrays used? Arrays are used to store multiple values of the same data type. Okay, so in this case, you can just use something like this. This is the syntax of arrays. We can have the variable name for that array to be marks. This can be the declaration of an array of size 100. Now this is the data type. This is the variable name. Okay, var name. And this is the size of the array. Size meaning how many integer values it can hold. Okay, so now when you want to take in an input, you can just run a for loop if you want to and take in input from the user, like from the terminal. You can just type in the individual marks and you can store it in the marks array. Now we will talk about it, how you can add values to it, how you can update, how you can access and so on. But this is what the typical use of arrays is. We want to store multiple values of the same data type in this. Now, as I told earlier, this is how you declare. This is a declaration. Okay, we have given an example below as well. Now, int arr4, which means that arr is short for array. Okay, this is one of the most common variable names that you can use for array. You will see that a lot typically when you start coding arrays for the first time. So int arr4, this means that now when this statement is executed, what will happen? Your machine will try to allocate 4 contiguous memory blocks for integers. So if you remember, an integer used to store 4 bytes. Okay. Now let's assume these are the 4 bytes. 1 square is equivalent to 1 byte. Now when I say int arr4, it means that I need to have 4 contiguous memory blocks for integers. Okay. Now that's the best part about arrays. These are contiguous in memory. The addresses are contiguous. So This is how it will try to allocate. I don't have space over here, so it might look like this is a separate line, but assume them to be in a serial order. So this is bit number 0, this will be bit number 8, 16, 32, and this will start from bit number 0. I think bit is not necessary because we usually do the computations in bytes. Okay, so let me just rub this and let us continue with bytes. So this is the 0th byte, first byte, second byte, third byte, and it will continue from the 4th byte. So if the address over here, let's say the address is ending at a particular byte. Okay, so let's say this is ending at the 3rd byte in our RAM. So this will start from the 4th byte itself. It is not that we allocate 0 to 3 bytes, like 0 to 0, 1, 2, 3 bytes to the first element of the array. We will allocate 15, 16, 17 and 18 bytes to the second element of the array and so on. It will always be in a contiguous order. Now you would ask, what if such a memory is not available? What if I have used all the memories so that there is no contiguous block of 16 bytes available with me? In this case, it's 16 bytes. I mean, in usual cases, you won't face this situation, but the machines are smart enough to rearrange the allocation of the memory, and they possibly might try to squeeze out the 16 bytes for you. In a real situation, this thing might not be possible. You would not encounter such a situation. But let's say if you are declaring something like this, int array, and let's say you are wanting to initialize 10 to the power 9 values. Okay, so this might be complicated because 10 to the power 9, how much this is? One integer is equal to 4 bytes. 4 bytes multiplied by 1 kilobyte, 1 megabyte and 1 gigabyte. Okay, so this is equivalent to 4 GB. Now this is very much possible that your system doesn't have contiguous 4 GB allocated with it. So you might want to reduce the size of the array in such situations. Now let me just get rid of this so that we can understand how the declaration, like we understood how the declaration is happening. Let's try to understand how the definitions, what all different ways the definitions can happen. So usually when we declared any variable for the first time, okay, we used to assign it either in the same statement or in another statement. So let's say this was v equal to 5. So this we used to call it initialization. And this we used to call it a declaration, and both of them combined was the definition of the variable. In arrays also it's the same thing. It can be integer, it can be character, it can be anything. First of all, it can be of any data type. It can be a float, it can be a double. Okay, this is not bubble, this is double, my bad. I am facing writer's block writing a D. Okay, so it can be any data type. Okay, first of all, so in initialization, what you can do is you can initialize one element of an array at one time. You can initialize the entire array at the same time as well. So arr 0 equal to 1 means that the first element of the array is equal to value 1. If you wanted to initialize the second value, it will be arr of 1 and so on. You can just initialize it to any value. It is important to note over here that the numbering in the array data structure starts from the index 0. The first element has the index 0 and so on. So if your array has size n, it will start from index 0 and go till n minus 1. So now some of the different types of definitions that we can have is in the first type over here. Now in the first type of a definition, we are allocating a memory equal to 4 integers and we are also assigning the values to it in the same statement. So you can use curly braces and separate the values by a comma and then assign any value that you wanted to for all those 4 elements. Now what would happen if I just assigned a couple of values and left it empty? Like for example, something like this. What if we did int arr of 4 equal to this? Let me write it in the back, which is the 4th example in this case. If you notice, in 4th example also we are trying to do a similar thing. So what will happen is for the 3rd and the 4th element, it will assign the default value, which is 0 over here. Now the 5th type of definition is a different one, because in this what your expectation would be, it will assign only the first value to be 0. But if you notice very carefully, since the value of the first element is 0 and we have not provided the remaining 3 initializations, it will automatically assign all the values to be 0. So explicitly and implicitly, what this fifth type of definition does is all the values of the arrays will become 0. So this is this helps with brevity. You can reduce the code that you are writing and assign all the values equal to 0 in one line itself, in one statement itself. If you look at the second type, it is a little bit different than what we have been doing till now. What we have been doing till now is we are explicitly mentioning what the size of the array is during its declaration itself. Okay, we are mentioning int array4 everywhere, wherever we have declared. But what if we don't mention it? Does it create an integer array of infinite size? No, that's not the case. So if you try to define it in this way, wherein we just write int array followed by an empty square bracket, and then we write 1, 2, 3, 4. So this will implicitly try to convert it into an array of 4 elements. Now, what if instead of 1, 2, 3, 4, we had 1 and 2 only? So in this case, it will not automatically add or update the remaining 2 values which we are expecting it earlier to be 0. Okay, in this case, what the compiler will do is it will create an array of only 2 elements. And once the size of an array is defined, you cannot change it. It is not possible that first we write int array4 and then we try to update the size of it. We will try it out in the code as well, just to check how we are doing it. And the third one is one of the most common one. Let's say we are getting the values which are supposed to be assigned to the array in a sequential order. We can write a for loop for n number of times if the size of the array is n, and then we can update the values of individual array elements to some particular value. It can be same value, or we can take the inputs from the user as well. But let us just try to solve some of the doubts that we had while discussing the arrays. Let's say I just do a empty size declaration followed by 1, 2 in this. So according to me, what I feel is it will assign 2 integer elements to array. Okay, I think speaking array is a bit confusing. Let's say A only. In this case, A is an array. Okay, so in this case, the compiler will assign memory equivalent to 2 integers to the variable A, and those will be sequential in the memory. Now, for example, if I wanted to update, if I wanted A of 2, which is the third element of the array. Okay, remember zero-based indexing whenever you are doing any operations with arrays. Let's say I wanted to do something like this. Do you think this will compile? I think this will fail in compilation itself. Okay, it has compiled. So now I'm curious what the output for this is. Let us try to print in a for loop what the individual values are. So we'll initialize I equal to 0, and then we'll run the for loop for 3 times, and we will try to increment the value of I every time the loop is running. Let us print A of I. Now let's try to compile it again, and then let's run it. So if you notice, now this is interesting because even though I updated the A of 2 value, I updated A of 2 equal to 3, it is still printing 3 in my case. Now it should have been 1, 2 and 3, but instead it's printing 1, 2 and 2. So I think it's time to invoke one functionality of array, which prints the size of the array. Okay, so array name dot size, this is the syntax which is used to get the size of the array. So any type of a declaration, it can be an empty size declaration, or it can have a declaration with a fixed size. Now if I try to do a dot size, this is the syntax of how I can get the size of the array which has been declared. It will return me the number of elements it contains. So let me just try to print this. Let me just try to add a string in front of it as well, some message, so that we know this is the size. Okay, so it throws me an error which says request for member size in A, which is of non-class type integer. Now I think it is time to invoke the special operator for sizes. So we will use the size of operator in this case. What size of does is, for example, if I did size of A in this case, or R, okay, if the name of the variable is R, integer, it will return me the total number of bytes which are occupied by this. So in this case, if there are 4 integers, then 4 cross 4, it should return me 16. So let us first try and print what size of A is in our case. Array size in bytes. Okay, this is not returning me the number of elements in this array. It is rather returning me the number of bytes occupied by this. My bad, this is A. Now let's try to execute it. It compiles and yeah, if you notice over here, it says array size in bytes is 8, which means that we have allocated only 2 elements to this, right? But somehow it is trying to get some unknown value for, so our output for size of A was 8 because we only declared it for 2 elements. If you notice in line 11th, we are only adding 2 elements to it. So whenever the compiler compiles it, it will only allocate memory for 2 integers, which is equivalent to 8 bytes in this case. And now this is coherent with the fact that when we are printing the array size in bytes, it is also returning 8 to us. But I think the compilers have become a bit smarter, because like in my college time, this used to throw me an indexing error that A of 2 doesn't exist. So somehow, let me also print the element value. Like what is the index? And value. Okay, so instead of 3 times, let me try to execute it 10 times and see what is actually happening behind the scenes in the code. So it still compiles, and when I try to run this code, okay, if you carefully notice that 2 was not equal to the last value that we have added in the previous initialization. Okay, when we perform this operation int A with an empty size 1, 2, and then we try to update the value of second element to 3. If I'm not wrong, it was 3. Yep. So now this 3 is not taken into consideration by our code. And if you notice, why is that the reason? We are printing 10 values, but we have only assigned 2 integer values to it. Rest, all of the values are some gibberish garbage. So if you are not careful while trying to access some of the array values which you personally have not initialized or defined in your code, you can expect some unexpected things. I know this is an irony, but this is how the compilers have become smart to not throw an error to you, but you also need to step up and understand where your code is not in sync with what you actually wanted to do. So if you are initializing only 2 elements and then you are trying to access the 10th element out of it, your code can behave in unexpected ways and it can lead to potentially damaging things as well. Alright, now this was a learning for all of us, including me, how efficient our compilers have become. They do the smart thing and they don't throw an error. But on the same hand, we should try to avoid such mistakes which are in our hindsight. Like we are not expecting them and somehow we missed out on that particular thing and it is leading to unexpected things. So what was the moral of this particular exercise that we did? That you should try to avoid initializations or declarations with empty sizes, because they can then ultimately lead to unexpected things. Now let's say if I had initialized it earlier. Let's say if I initialized it for 3 values, which means that the third value would be equivalent to 0. Alright, let's try to execute the same code again. Now if you notice, till the third value, index 2, it is giving me the correct answer and has the value equivalent to 0, which it should have been. But it is still trying to throw gibberish values if I'm accessing more values than that after index 2. Okay, and if you carefully notice, the array size in bytes which is printed on the top has also updated from 8 to 12, which means that whatever initialization I was doing in line number 11, it leads me to a memory allocation equal to 3 integers. Now this is how in different ways you can initialize, declare and define your arrays. Now some of the properties of the arrays which we also have been talking since the beginning. The first one being the array elements are stored in a contiguous memory location. We will try to understand this in more detail when we talk about pointers and references at the end of this module. So this will become more clear then. Indexing of an array starts from 0. This should not be missed out. Let's say if you expect the indexing to start from 1 and go till n, you might face unexpected values for the last value, and what you expected to be the first value will in fact be the second value, and so on. Like the consistency of the program is completely different. After an array is declared, its size remains constant throughout the program, which is true. Like initially, if we checked earlier, the array size that was allocated was 8 bytes. In the second modification, it was allocated for 12 bytes. But even though if we try to add more values to it, it's not changing the size of the array. Okay, now this is a very careful observation. Now the second part is, now this is the last part and very important part is, it can have multiple dimensions. Now over here what we did was we had a single dimension array wherein, like if I had int a of size 4 and assign 1, 2, 3, 4 to it, this is what I would call a single dimension array. Now if I had two dimensions, which you can say x and y axis for example, so we can declare it in this way. For example, it's a 4x2 grid. Okay. So now what this means is that we have 4 columns to it and there are 2 rows. Now indirectly this means there are 4 arrays of size 2. Let's try to check it out. What does this mean? Does this mean it has 4 arrays of size 2 or does it mean it has 2 arrays of size 4? Let's try to initialize both of them and let's try to see what happens actually. Now I will take a smaller example and try to check for 3x2 array. Okay. So this means there are nested arrays within an array. So let's first try to check the hypothesis that there are 3 arrays of size 2 each. And if that fails, we will check for the other option. Let us also try to print. For the time being, let's avoid printing what the individual elements are inside the array. Okay, let's first try to see if this compiles or not. This compiles. And the output is array size in bytes is 24 because 3x2 there are 6 elements, and what we are actually doing is we are allocating memory for 6 elements which are spread across 2 different dimensions. Now let's try to do the opposite thing and let's try to see if this again compiles or not. Maybe we are missing out on something. Okay. So here it says too many initializers for int 2, 3, which means that if you check the slide, now what this declaration means, there should be 2 integer arrays and inside each of these 2 arrays there should be an array of size 3, which means that we could have an initialization something like this. So this means there are 2 arrays overall and in each of these arrays there are 3 elements. But if we move the definition to what we did in the code, this will lead to an error which says that what you are trying to do is actually initializing 3 arrays of size 2 each, wherein you should have done the opposite thing. Okay, so let's just try to correct this mistake and let's try to see how we can access all of these values. So first of all, we realize that there are 3 arrays in this and each of these has size 2. So we will have nested for loop for this to access both the dimensions. So now let's just print both the values over here instead of printing the index as well. Let's print the value of I first, followed by the value of j, and then we will follow it by the value of array of I comma j. Now we'll just add a space in between for visibility. And then how we are accessing it? We are accessing it using the same way how we were trying to update the values. What array of I comma j will do is it will try to access in the first for loop, it will try to access a of 0 comma 0. Now inside the loop of I, there is another loop of j. So first for I equal to 0, there will be a loop from j equal to 0 to j equal to 1. And then we will update the value of I from 0 to 1, and then we will run the same for loop for j as well. Now let's try to see how the values are printed. The compilation is successful. Now if you see, this is how we initialize the elements. Now this is in coherence with what we had expected, and we also checked how we can access the values. So in this way we can have multiple dimensions. We had just 2 dimensions over here. We can have 3 dimensions as well, wherein inside an array there will be an array of arrays. Okay, it seems like Inception, wherein there is a dream within a dream within a dream and so on. And similarly in arrays also, like nested loops and nested conditions, if and else conditions, we had nested conditions. We can also have nested arrays. Okay. So now we already covered the part wherein we checked how we can access any element using the index. So for example, if I wanted to access the third element of the array, so I can just use a of 2. Okay. Now again, just trying to reiterate on this part, an array is 0 based index. So a of 2 will give me the value of the third element. So when I try to use this, let's say I want to add the value of the third element and the fourth element. So I can do something like this, and I can just print it out if I wanted to. I can assign it to some other variable as well. I can do anything I wanted to with these 2 values. So in this way you can access the value of any element in the array. In the same way that we accessed it, we can update it as well. If we want to update, like let's say it was initialized, array of 3, 2 was initialized to 1, 2, 3, 4 and 5, 6. Let's say I update the value to something else. Let's say I update the value of the first element to 100. I can just write this statement and let's try to print the array once again. So I'll just print a statement new array so that we know the difference between the new array and the old array. So if you see in the new array, the value of, like in the first array, the value of the first element inside the first array is updated to 100, which initially was 1. Okay. So in this way you can access the value of an array and you can also update it. And you can also run a for loop if you wanted to access or update any values. Like this is one of the most common ways. If you wanted to do something in a batch for all the elements inside the array, you could do that. Now there are some STL operations. Size was one of them, which I talked earlier, which gives us the size of the array in bytes. This is a wrong syntax. We can use, this is also wrong. We are not using STL operations over here, first of all. So if I wanted to get the size of an array, we will use size of operator. Size of A will return me the entire size occupied by A in bytes. For example, if I wanted to know how many elements are there inside the array, what I could do was divide it by the size of integer. Okay, so now size of A would be equivalent to 24 in this case because we have a 2D array of 6 elements. So it will be 24 bytes overall, and size of integer is 4 bytes. So this will give me 6, which is the number of elements in this array. So let's try to check if this is true or not. Let me just update the statement that we were printing earlier for the size. So instead of bytes, we'll print the number of elements. So yes, it gives me the size of like whatever the number of elements are there inside the array, it gives me the same number that we were expecting. So in this way, you can use the size of operator to get the size of the array. And now moving on to a very important part of C++ programming language, which is strings. Now strings is a very important data type in C++ because for any textual processing, you would need a data type which can help you process text. So the data type for strings is as simple. I mean, string is the data type which we'll use. And let's say if I wanted to initialize something, it would be as simple as string s equals to hello world, for example. In the same way, like if it was an integer, what we did earlier was int a equal to 5. In the same way, we can define a string by having the data type, the variable name, and whatever value we wanted it to be assigned. Now there is another way in which a string can be initialized. String s, and in the round brackets, you can just add the string that you want to. Hello world in this case. And this will also do the same thing as our previous initialization was doing. So let's just try to do the same thing as I discussed, and let's try to see if this works or not. So what we'll do is we'll first define the strings and then we'll try to print it as well. And let us comment this once again. So string s, let's say the string is hello world. Now let's define another string t, and we will use the same string for this, hello world with t, just to be different. Now we can output the string in the same way that we were doing for other variables. We can print s, and same thing we can do for t as well. And let's try to see if the code compiles or not. For it does, and let's try to see the output. It does as expected. Now both the initialization works, both of them are equivalent. Like if you have a preference, for example, I prefer the initialization on line number 27th because it is similar to the other different types of initializations which I use for integers, arrays, and so on. So I would prefer that, but if you are more comfortable with the second type of initialization, feel free to go ahead with it. Now we also checked how you can output the strings in the same way as other data types, and in the same way you can take them as input as well. Let's try to take a string as input, and we can also print it later. String a, add a string. We can just ask the user to add a string. And we can then print it back to the user. Let's try to compile and run the code. Add a string. Let me type my name. The string is Aanshul. So in this way, you can take the input of the string. You can do the output of the string as well. Now, this was quite trivial because we were doing this for other data types as well, and this was very intuitive to us. Now, there are some other operations. One of the most frequent operation is string concatenation, which means we try to add both the strings. When I say add both the strings, this is not a mathematical addition. This means we try to merge both the strings. For example, string 1 was hello. Okay, s is equal to hello and t is equal to world. Now we can just do s plus t, and then it will give me hello world. Now one thing to notice over here is it will not add spaces on its own when you are trying to add strings. So if you wanted to add a space, either you can explicitly tell that s plus some space plus t, or you can in one of the strings s or t, in s you can add the space after the string, in t you can add space before the string, and so on. In that way, you can explicitly try and add the string. Let's try to do the string concatenation. I will update the strings for hello and world for S and T, and we can try to replicate the same thing. So this should give us the expected output of hello world. And it does. So we can use the plus operator. For numbers, it will do the addition. For strings, it is doing concatenation. Now this is something which we call operator overloading, which we are going to talk in detail in the object-oriented programming module, which is a module 3 of this course. And we'll talk about that in detail, not for this module. So what we have covered is how strings are defined, how we can take strings as input and output, how we can do string concatenation. Now there are some other type of concatenations and some other operations that we can do on top of the string. Now first of all, it's important to realize what happens when I declare a string. Okay, when I define a string s equals to hello world, what happens? So string actually is an array of characters. So let's say hello world has 1, 2, 3, 4, 5 and 5, 10 and 12. It has 12 characters. Okay. So what the compiler will do is it will allocate the memory equivalent to 12 characters, which is 12 bytes, because one character was equivalent to 1 byte. So this memory will be allocated first. In the first byte, capital H will be stored. In the second byte, E will be stored. And in the same way, the 12th byte, exclamation mark will be stored. Okay. So this is an array of strings, and if you wanted to access one particular character, you can do it in the same way that we did for the arrays above. So let's say I wanted to print, which character can we print? We can print the second character, which will be index 1 of the string s. Okay, let's try to compile it. And then on running it, it prints E, which is the second character of hello. So it works as expected. And in the same way, you can update an individual character inside the string as well, using the array syntax that we discussed earlier. So string element access and update is covered. If we wanted to update the string altogether, we do it in the same way as we did for other variables as well. So we could just do as is equal to hola instead. Okay. So let's just try to update it, and then we can see what happens in the output. Compilation works, output also works. So if you notice, the addition or the concatenation of both the strings returns hola world, and the second element of the string s is o now. So in this way, you can update it as well as in the same way as we did for other variables as well, like other data types variable as well. Now, how can we concat strings? We checked the second way right now. These are two other ways in which you can concat the strings. The destination means that, like over here, we have two strings, destination and source. Now, when we try to do I would really recommend at this point that you try to pause the video and then execute the first type of concatenation and the third type of concatenation. When you do destination.append source, what it does is it updates the destination string to destination plus source. Okay, so the string is overwritten, the destination string is overwritten, and the source string remains as it was earlier. So we can try to copy this thing and try to see if it works as expected. String s.append t. Now let's try to print both the strings, and we can see what has actually happened behind the scenes. So now let's try to compile the code first. Expected initializer token before dot. So it says expected initializer before dot token. Okay, let's check what the error was. All right, we didn't need to add the string in front of s.append because it's already been declared what the data type is. So we just need to write s.append t, and it should give us the expected output. Now when we try to compile it, it does this time, and the output is for S. You can see like the string S got updated to hola world, whereas the string T remained as it was before. So if you want to keep one of the strings same and you want to update the other string, you can use this syntax. So we tried to check how the first type of concatenation happened. Let's try to see how strcat is happening. Now this is the third type of concatenation. Now in this case also, destination is the S and source is T, so source won't change, and the string in S should get updated to hola world. Okay, it says strcat was not declared in this scope, and it also suggests us to add the particular header file for this. Now the compilers have become smarter than it were earlier. Earlier it just used to throw an error. Now it is also throwing me a suggestion that, hey, did you mean to include C string as well? Because it seems that strcat is present in that particular library. So let's try to follow that suggestion. Hash include C string, and let's try to compile the code again. Now it is throwing me an error again. It says cannot convert std string to char star. So this means that this might work on an array of characters, but this might not work on string. So let's try to initialize them to characters and let's see if this works or not. First of all, this can be let's just try to compile this once again. Okay, now there are more compilation errors. Okay, I think I should not have used the char pointer over here. I added it by mistake. Now it compiles, and if we try to check this, the output for S is hola world and T is world. So now we also learn another type in which we can initialize the strings, which is an array of characters. So strcat is applicable only on array of characters. Okay, and both of these types are applicable on strings. So this is also equivalent to string, but the implementation for that particular library expects it to be of a particular data type, to be of a particular explicit data type, which is char star. Okay, so this is also equivalent to a string. It will behave in the same way, but strcat library is meant to expect the source and destination string of type char star. Now you might be confused by what the star was, and I think it will be more clear when we talk about pointers in future in this module. Now that was it for strings. I mean, you can try out, there are some different operators for copy also. You can compare two strings by, in the same way as we compared the integers, as equal to t, you can just compare it and try it on your terminals, try it in your code if this works as expected or not. You can just try and do if s equal to t, you can print both are equal, else they are not equal. You can just try to execute that and see if it works as expected or not. But before doing that, you would want to, I mean, it will be valid only on the string data types. It might not be valid on char star data types. So you will want to change the data types of s and t to string, and then you can try the same thing again. So I'm not going to do it in this particular code. I mean, I'm leaving that as a friendly exercise for you to try and explore what all different provisions are there for string data type. Okay. Now moving on to a very important part, which is functions and scope. If you remember, all our C++ code had this int main. Okay. And we had this return 0 at the end of the code as well. Return 0 means end of the code, end of the execution of our code. Now int main, this is actually a function. Okay, this is a special type of function which tells the program, which tells the system that, hey, the name of this function is main and you need to start the execution from this function itself. Now what is a function? Function is just a block of code which you can use for modularity. For example, you can have a function to compute maximum of 2 integers. You can create a function to add 2 strings and return whatever the concatenated string was, and so on. You can have different types of functions. They can be trivial, they can be non-trivial as well. But the purpose of functions is to try and abstract some functionality out. Okay, you can just directly call the function and it will do the thing for you. For example, over here we used strcat function. Okay, we didn't know about functions, yet we used the function which took in 2 char star data types and tried to perform concatenation on top of it. We don't know how it was executed, what is there inside the function as well, but we know for sure that it is returning us a concatenated string. And that is the main power of functions. It abstracts those utilities out for us. So what is the normal signature or normal nomenclature for a function? There will be a return data type. Okay. What the output? There will be some output from the function, or there can be empty output as well. Let's say we just wanted to print something inside the function. So we can have an empty data type, which is void in this case, which we didn't cover in the first module. But you can use void if you don't want to return anything at all. And then instead of returning 0 or something, you can just write return followed by a semicolon. This will return the function whenever you want to. So now the first thing that you want to write in a function is the return data type, the data type of the output. Then it will be followed by a function name, and then you can have as input, you can have multiple variables. Okay, you can have, then you can do some processing on top of it, and at the end you can return whatever data type you wanted to. Let's say I want to create a function which adds 2 numbers. Okay, so what I will do is, it's an integer. First of all, what I want to do is addition for integers. For booleans, I will write a different function. If for doubles or floats, I would write a different function. So int add, I can just take in 2 integers, int a and int b. And then in the code, I can directly return a plus b. Okay, so whatever I am returning, this should be of data type integer. Let's say I return true. Then this will implicitly be converted to 1 because 1 is mapped to true and 0 is mapped to false, which we talked about earlier. So return data type, an important part. Then the function name, because that is how we are going to invoke it. Now what happens if I keep the return data type as integer and then don't return anything at all? I think it should throw some error. We can try and check it out as well. Then there will be some input. And this input can be of different data types. It can be a string, it can be boolean, it can be integers and so on. It can be anything. And then there is a code block within that function. So let's just try to write our first function. Let me get rid of all of these code which we had been commenting since a long time. Int add, and then instead of returning something, let's just not return it. Let's perform a computation for addition a plus b, and then let's keep our function as it is. Let's try to see if this compiles or not to begin with, and then we can see how we can access the output. So first of all, it doesn't return anything, and it says no return statement in function returning non-void. First of all, this is a warning, this is not an error, so it still might get executed, but we need to resolve the error, which is a and b are not defined. So let's define them. Okay, let's try to execute it. It will execute, but nothing is returned. So it allows us to have an empty return type, but it also suggests that you should add something, you should return something so that the signature is fulfilled. So over here we can just return C, which is the addition. We can also directly return A plus B as well. That is also completely normal. And let's print the output. So now it prints a plus b equal to 11. So this is what we had expected, and in this way you can create a function, you can define it on top of your int main, and then you can invoke it Like one function can be invoked from other function. Now if you remember, I also talked about there will be some class definitions, there will be some function definitions as well. So this is how function definition looks like, but we cannot define it below the int main function. Why it is so? Because if you notice in line number 8, we are trying to call add a comma b, but at that moment, the compiler has not found the definition of that particular function. So it will say that no definition has found. Let's see what the compilation error is. So it says add was not declared in this scope. Okay. So this means that the order of the functions should be in such a way that the function which we are trying to invoke, there should be a definition and declaration of that function on top of it. Now let's try to declare it first. Let's try to, now this is the signature of declaration. We just mention what the name of the function is, and we just mention what the input data types are and what the output data types are, and this will run as expected. Now this has compiled and this has also run as expected. So it is important for our declaration to be before the usage. We can define it later as well. So we understood how the declaration happens, we understood how the definition happens. So this is a declaration. And this is how we define it. Like definition is the entire function, how it should be executed, what should be executed, and so on. Now let's try to understand the scope of variables in this case. Okay. For example, I am adding a new variable c in add function. Can I access it outside the function or not? So it says C was not declared in this scope, which means that there are different scopes in our code. Let me just try to copy the code. There is another function int add over here. Now there would be some variables which are declared in int main function. There would be some variables which are declared in add function. So whenever the execution of this function ends, all the variables which were declared in the scope of this function will be thrown out. We will get rid of those variables. We will also free the memory. Okay, so it's like a stack. So for example, a and b were declared in main. Okay, so a equal to 5 is declared in main, b equal to 5, b equal to 6 is declared in main. And inside main we are calling add. So we are defining a function, we are defining a variable c, and then we are updating its value to 11. So this is the add function. Now when the execution of add function is over, when we return c, this is removed from our memory, and we only have access to the variables which were declared in the scope of the main function. Okay, so we need to be very cautious when we are trying to access some variables which are not actually defined in the scope of that particular function. Now, what if we wanted to access C? So this is where references and pointers come into role, and in the next section we will talk about that. Now, first of all, what are pointers? Pointers point to some memory, like pointers point to some address in our memory. Let's say we declared an integer a is equal to 5, and we also declared a pointer int star. This is the syntax, this is the data type of a pointer, which is equivalent to the address of a. Okay, so now ampersand shows us the address, like this is the symbol which we use to get the address of any variable. When we use ampersand a, this means we are trying to fetch the address of a in our memory. And when we are assigning it to p, it means that p points to that particular address in memory. To just make things simpler, let's say the address of a was x123. Okay, just giving some random name. So this was the address, x123 is the address, and it contains a is equal to 5. Okay, it will actually contain only 5. It will not contain a equals to. Now, when I execute this statement, it creates an element of type int star, which is a pointer, and pointer, if it's a 64-bit machine, okay, the addresses will be of size 8 bytes. If it's a 32-bit machine, the address will be of 4 bytes. So in my case, it's a 64-bit machine, so address will be of 8 bytes. So in this case, int star p, it will create a new variable. We can refer the first variable by a, we can refer the other variable by p. And in the variable p, we will store the address of a, which will be x123. Okay, and the size of x123 will be equivalent to 8 bytes since my machine is 64-bit. Now p will also be having some address. We can create such, like we can create a double pointer, we can create a triple pointer, and like such sort of crazy things can be done. But at this scope of this module, they are not important. So let's just try to execute this and see what is actually happening. Okay. Now I have tried to explain this part over here. Let's just try to replicate this in our code. Let me try to get rid of the add function call. Now int star p equals to address of a. First of all, we can't do int star p is equal to a, because then the data types won't match, because the data type of a is integer and data type of p is int star. So we need to get the address of a and then only we can assign it to p. Now we want to see what the, first of all, let's check the address of a, which is stored in p. So if we try to access this, like this is some hexadecimal. I think this address is shown in hexadecimal, and it shows me the address of a. Now, if you carefully notice, p is equivalent to address of a. Let me try to add in the comment so that it's clear. P holds address of a. And when we want to try and get the value of a itself, we can use a star p, which is called dereferencing the pointer. When we dereference the pointer, we get access to the value which is stored at the address in p. Okay, it might sound a bit complicated, but star p is dereferencing. It accesses the value stored in the address of p. Like there is some address stored in p, it will try to look what the value is inside that address. Maybe like the comment is not so helpful, but I think like the statement that I gave would be useful to you. So let's just comment and run this code. So we see star p prints 5 for us, which is the value at the address stored in p. Now I can update the value of p by using the same thing, like star p is equivalent to updating like a is equal to 4 and star p is equal to 4. Both of them are the same things. So we can update the value of p in that way. Now I talked about double pointers and called it a crazy thing. Why is that so? I would not try to do that. The reason is, let me just try to copy the same thing earlier, which I did earlier. Let's say the address is x123, it stores 5. Let's say the address of this is 456 and it stores x123 in it. Now when I do int star star double p, okay, now this should store the address to a pointer. So this should ideally be storing x456 if we are assigning it to p. Okay, so if we are doing int double star double p equals to p ampersand of p, then it will store the address of p in the variable double p at some new address. But this can be a tricky thing because at this moment we get confused that double p is the address of what variable, and on dereferencing it what exactly we will get. And if I try to update the address, let's say I try to update, like if I try to dereference double p and try to update it to 5, for example. Now what we actually did was we changed the address which was earlier there to 5. Now changing the address can have a lot of damaging implications. Let's say I tried to do double star of double p, which means that I'm trying to dereference whatever value is there at address 5. Now I actually don't know what is stored at address 5, because in my case I only had the knowledge what was stored in x123 and x456. Now this can be damaging. So I would not recommend you to try it at your systems, and I would certainly not do it in my system as well, unless you're confident and you know what is actually happening with the double pointers. Okay. So now, let's say we try to replicate this thing where int end of R is equal to A. So do you think this will create new memory? This is known as reference operator. Okay, this is like reference data type, you can call it. This is the reference data type. We will use ampersand for that. And what it does, it will just alias it. It will not create. For example, in int star p, what it did was it created a new value to store the address of A. But over here, it doesn't store a new value. It doesn't create, it doesn't allocate a new, like it doesn't allocate new memory. It will earlier, like x123 was the address and it stored 5. We could access this by using A. And if we execute this statement, we can execute it by using both R and A, wherein the address of R would also be same as the address of A. Now this is known as reference, and if we try to execute the other part, it will create a new integer. It will allocate new memory to it, and both the addresses would be different. Now let's try to just replicate that thing and see if I'm lying or not, or if I know C++ properly or not. Now the first thing we will do is print address of A by using the ampersand operator. We'll try to do the same thing for R as well. And let's first see whether the address of both the variables are same or not. I hope I know C++ enough. Okay, if you notice, I didn't add a andl statement at the end for a new line, but both the addresses were same. So both the addresses are same, which means A and R are two variables. They just have different names, but they point to the same address and they contain the same values. This is same as me having some other nickname. Like for example, I don't have any nicknames, but for example, Virat Kohli has a nickname Chiku. Okay, so if someone calls him by Virat, if someone calls him by Kohli or Chiku, all of them point to the same person. Okay, so this is what reference data type also does. It doesn't create a new, like it doesn't create or allocate new memory to the variable. Whereas on the other hand, we know if it was instead of ampersand R, it would create a new address. Let's try to verify that. And if you notice, both the addresses are different. Now we just want to do one comparative study at the end to understand the difference between passing by value, passing by reference, and passing by pointer. Okay. So for that purpose, like when we pass in a function, when we pass something by value or reference or pointer, there are different implications of it. Let's create a function which takes in a input by value. We can take in an integer value itself. For example, this is f1, like just some random name. It will take an integer and we just want to update the value of A to be A plus 20, let's say. And then we will return A. Okay, in the same way, we will also pass by reference and we will also pass a pointer. And we will name it F3 and F2. Here we are accepting a reference and we are accepting a pointer to A. So in the function 2, if you carefully notice, we are passing a reference, which means that it will not create a new copy of any integer. But in F1, when we are passing int A, okay, it will create a copy of that variable. It is similar to, let me break it down and write it as well. In F1, we are taking the value, taking the variable by value. So what it will do is, let's say we are calling F1 of 5, okay, F1 of some other variable. Let's say this was X in our int main function. So there will be some memory allocated to 5 and it will have some value. Let's say x was equal to 5. Now when I call f1 function, what it will do is it will create a copy of the variable x. It will create and allocate memory to the variable a. It will create a copy of it and assign the same value. Now this is in f1 function and this is in main function. Now when the execution of f1 function is complete, this will get rid. So if you are updating the value of a to be a plus 20, ideally you should not see the difference when you are returning the value in the main function. Okay, we'll just try to see this hypothesis. We'll just try to check what our output is. Okay, let's initialize a to 5 and let's get rid of all the other stuff. Let's also add some statements inside the functions to see how the values are updated. Now when we are passing by reference, let's print the addresses as well so that you can realize what I was saying, that it allocates memory to the new variable whenever we are passing by value, and that does not happen whenever we are passing by reference or pointers. Pointer is basically we are passing the address of that particular variable to the function. So obviously it won't create a copy of that variable, but it will definitely create a copy of the pointer with it. But that pointer stores the same address, so that's completely fine. Let me start with a flashback from the first module about C++. If you remember, I told you how C++ was born as a programming language, right? So let me just cover that part once again so that you have an idea why object-oriented programming is so important. Okay, so before C++ was conceptualized, it was known as C with classes, and that was the primary reason, the primary reason for C with classes to be conceptualized by that PhD professor or the person who was pursuing his PhD thesis was that he was working on a programming language Simula at that time, which was one of the most primary programming languages which had object-oriented programming paradigm, which was not there in C at that time, but C was fast. So that person thought of merging both the benefits into one programming language, and that's how C with classes was born. He tried to add the object-oriented programming paradigm into the C language, and hence it was known as C with classes, which was renamed to C++ later. So one of the main reasons of C++ to be born as a programming language was it had object-oriented programming paradigm with it. Now you might be confused, like he keeps on speaking object-oriented programming again and again. What does it actually mean? To throw you another technical definition, technical jargon, which you will surely understand when this module ends for sure. Okay, it means that you have the capability to define classes. Now what is classes? Classes are user-defined data type. For example, int is a predefined data type in C++. Classes, structs, all of these are user-defined data types. So you can define classes, create objects from them, and then you can have objects interact with each other. So I know all of these is still a technical jargon, but I am going to cover all of the dimensions about object-oriented programming in this module from the very beginning. So you use classes which are defined by the user, make objects out of it, and these objects are used to... Now, what does a class have? A class has data members. You can also find the analogy similar to what variables are. Data members, then the classes have member functions. And classes have something known as access modifiers. Apart from that, there are 4 axes of object-oriented programming concepts. Let me just get rid of the history lesson. Okay. So now there are 4 main pillars of object-oriented programming, and these are similar in all the languages if the language is object-oriented programming. Okay, it can be Java, it can be Python, whatever language is OOP compliant, object-oriented programming. Then it should have these 4 axes covered. The first one being encapsulation. The second one is abstraction. The third one being polymorphism. And lastly, we will have something known as inheritance. So these 6 components, class, object, encapsulation, abstraction, polymorphism, and inheritance. These are the 6 main things which can cover all the concepts of object-oriented programming paradigm. And other concepts are peripheral around it, like if I throw some technical jargon once again, then abstract classes and all of those are closely related to one of these concepts itself. Okay, so now let's get started. So I told you something about structs. Now what are structs? I didn't define it in the first 2 modules, and we are not going to cover it in detail in this module as well. But structs is a user defined, first of all. What is struct? Struct is a user defined data type. Now what does it do? It binds different data members within it. And what can be the data members? It can be structs itself, it can be integers, floats, boolean, it can be any other data type. So struct is kind of binding different types of data that we want in an entity. For example, person is an entity. Now what does the person have? They can have name, age, gender, occupation, and lots of other details included in it. So this is how, this is the syntax of struct first of all, and this is how you can define a struct and use it. For example, we had int a in one of our previous modules. This was the declaration of an integer. So similarly here, the data type of the structure is person. So you can have person p or any name you want to give it. Person is the data type over here, and this is user defined data type. Okay. And if you want to access any of the data members of a struct, what you can do is p.name is equal to, let's say, Aanshul in this case, in my case, and so on. Like you can change any data member inside it, you can access any data member inside it, you can just play around with it. Let's say it was for students, then you can store marks like English marks, mathematics marks, and so on. And this one data type will encapsulate all the other data types which are relevant for that particular entity. Now you might be wondering why I'm talking about struct when I was supposed to talk about classes. Now taking it a notch higher, how classes are related to structs? Classes are also user defined data type. User defined data type. But instead of just data members, as I told earlier, it has 3 entities, 3 main entities. So classes will have data members, which is similar to struct itself. Like they can be variables of different data types. It can be a struct inside, like the data member can be a struct, it can be integer, float, boolean, string, whatever we want to. There can also be arrays. Okay, so any data type can be a part of classes. And I will usually use the term data members or variables interchangingly. So I am hoping you won't get confused throughout the duration of this module. Then next would be member functions. Now the main reason why classes are defined is to bind these data members with the member functions. These member functions have access to the data members. They can access them, they can tweak them, they can do any processing on top of them. Okay. So these I can interchangeably use functions or methods or any other name for it. So till now, in the first 2 modules, you were introduced to variables and functions. And you can continue with that analogy that data members are actually variables and member functions are actually functions. And lastly, access modifiers. which is going to be something new for this particular module, which we have not covered at all in the first two modules. Now, what are access modifiers? They control how you access these data members and member functions. Okay, so first of all, these data members can be accessed by any code outside the classes. It can also be accessed by the member functions, and it can also be accessed by the child classes. Now, child classes is some technical jargon I use which I have not explained, but I will be covering that in detail in inheritance concept. So just remember this thing, that access modifiers control how your entities inside a class can be accessed. Okay, so what are the different types of access modifiers? It can be public, which means anyone can access it. Anyone can call the function. Like if a function is public inside a class, anyone can call that function. If a data member is public inside the class, then any function outside the class as well can access it. Then comes the protected modifier. Now this means that child classes can access those entities. It can be data members or member functions. Now again, I am telling you, we will cover child classes in detail in inheritance. So for the time being, ignore that there is something known as protected in the access modifiers. That will become more crucial as we approach the later half of this module. Now, last type of access modifier is private. Now, private means not everyone can access those entities. Only the member functions can access these entities which are defined inside the class. Okay, both data members and member functions can be private. And if a member function is private, it means that only the function inside the class can call that particular private member function. And if a data member is private inside the class, then only both private and non-private member functions inside the class can call it. But the restriction is anyone outside the class cannot call it. Okay. So we will talk about the code as well in a little moment. So when you see the code, you will realize what I actually meant. So right now, I hope the definitions are clear, like what are the different types of access modifiers, public, protected, and private, what's the major difference between public and private, and we'll also look into the code, what it actually means, and what are data members and member functions. To just give a real life analogy, for example, whenever I am cooking, I usually refer to recipes from YouTube or like some of the cooking blogs. So classes are similar to recipes. Okay, they are not actual dishes, but they tell you what are the ingredients, how you need to cook, and all the steps are provided in it. So similarly, the ingredients can be data members, and the recipe, like whatever steps are there, that okay, boil water for 20 minutes, boil pasta in water for 20 minutes, and so on. So all those you can consider them to be member functions. So it is actually, classes define how you can access that particular object, and you can just think of it being similar to a recipe. I'm not sure if it's a great analogy or not, but hoping that you understand, like whenever a dish is created out of a recipe, objects are created in a similar way out of those classes based on that blueprint. So class is like a blueprint. Okay, now moving on, let's first see the code. Understanding the code is really important. So for this module, I have actually written the codes. We can understand them in detail. So if you see on your screen, I have defined a car class, okay, and it has few of the entities, like model is there for string data type, mileage is there, which is a double, color can be there, and year of registration is there, which is an integer. Now all my class is, okay, first of all, in the access modifiers also, these are the keywords, okay. Public, protected, and private. These are the keywords which you need to use in order to define an entity as either public, protected, or private. And if you don't define anything, it means it's a private entity. So now, like if you look at the code, model, mileage, color, and year of registration, nothing is mentioned on top of them. But if you look at the member function, which is print color, it has a public annotation on the top of it, which means that print color is a public function. And above that, all the other entities, which are the data members, those are private, because by default the access modifier is private in C++ object-oriented programming. So now this means that model, mileage, color, and year of registration cannot be accessed by everyone. It can only be accessed by the member functions of that particular class, which means that if I wanted to access color, I could like call it within a member function, like I have done here in print color. Okay, so this doesn't create a car variable. First of all, this is just the definition, like integer is 8 bytes long and all of integer is 4 bytes long, and all of those definitions and signatures are provided, right, for a data type. Similarly, car over here is a user defined data type. Now we will understand how objects are created out of these classes in the next part. Now what are objects? So let me just give an analogy from the previous module. Like integer is a data type, and similarly car over here is also a data type. Now when is memory allocated to that particular integer? Whenever we declare it, right? If you remember the difference between declaration, definition and initialization, whenever we declare it, if this statement is executed int a, it will allocate 4 bytes memory to that particular variable. Similarly, if I use car c1, okay, this is just a variable name. You can use any variable name you want to. So this means that suitable amount of memory will be allocated to car data type to c1 variable. Okay, now what memory should be allocated? It should be necessary for string, which is string model. Now similarly, there is a double for mileage, there is string for color, and there is an integer for year of registration. So for these 4 data types, some memory needs to be allocated. But if you notice, both the strings don't have a fixed size at this moment. So there would be some buffer memory allocated to them, and actual memory management is dependent on the compiler over here. So let's take a look at the code, how an object is actually created. So now if you see, I have added some member functions as well, and I have added a data member which is on, which means that the car is on or not. It's a boolean. And I have changed some of them as well. I think there is double speed which is added, like what is the speed of the car at that particular moment. And something which you notice on the screen is like whatever the part is highlighted, it is known as a constructor. So whenever you create an object, you can pass in some variables, some values, so that they can be assigned to the data members of that particular class. So this is the syntax of a constructor. We won't be covering that in detail because constructors and destructors probably goes out of the scope of basics of object-oriented programming. It is a critical part, but we won't be covering that in detail, and without understanding them comprehensively, you are good to go with this particular module. Okay, so what is the syntax of a constructor? That we need to understand. Class name, over here it's car, but like typically it would be a class name, followed by a parenthesis. In this, there can be one or more data types. There can be 0 data types as well if it's an empty constructor. So 0 or more parameters. And it is similar to a function. First of all, if you try to find the analogy with our previous modules, it is similar to a function. And constructor is actually a function. So whenever, for example, whenever we did int a is equal to 5, what actually happened was 4 bytes were allocated in the memory to variable a, and 5 was assigned as the value for that particular memory. So whenever an object is created, the constructor is called. This is a user defined constructor. There is a default constructor as well, which the compiler uses if we don't define a constructor explicitly. Okay. So over here in the code, we have explicitly mentioned a constructor which should be used whenever we are declaring that particular object. So we can assign the data members, whatever data members are there, to these parameters. It can be param1, param2 and so on. I mean, looking at the code, it will give you more clarity. So we have taken 3 parameters, int m, string c and string mdl. Mdl stands for model, c stands for color over here, and m stands for mileage if I'm not wrong. Yep. So if you see inside the constructor, what we are doing is we are actually assigning values to the data members of that particular class. Okay. For speed, we are not passing any parameter. So what we are doing is we are assigning it to a default value 0. At that time, because it makes sense. Right now the car would be we are just creating the object for car, so its speed would be 0, and is on is also assigned to false because that is also intuitive. For the rest of the attributes like model, mileage and color, we are assigning the values which we have passed as parameters. And if you notice, I have added a couple of other member functions as well, turn on and turn off. If turn on member function is invoked, then we change the is on data member to true and vice versa for turn off. Okay, so now this is how car C1 followed by a parenthesis and those parameters that we talked about earlier for mileage, color and model. This is what we can pass if we want to construct that particular object. So whenever we call this function or a constructor, okay, car C1 followed by parentheses and those three parameters that we defined in the constructor earlier, it will create memory in the RAM for that particular object C1 of data type car, and it will assign those values as we have mentioned in the public constructor. Now the constructor needs to be public if you want to invoke it from outside the class. So here in line 35 you can see this is outside the class and this is invoked from int main function. Okay, so the constructor needs to be public. A constructor can be private as well if you want to invoke it from within those member functions itself. And then we are calling c1.printColor, which means that it will call the printColor member function and it should be printing that particular statement. Let's try to compile this code and we can run it as well. Okay, it's compiled, and on running it, it says car's color is white. So if you notice in line 35, we were assigning the color white, like we were passing the color white, and in the constructor, we were assigning it on line 17. And in line number 22, that member function is trying to access that particular color attribute. So if we were to call c1.color, okay, this will be a revision for the access modifiers as well. If we were trying to call c1.color, this should throw an error that color is a private attribute and it cannot be called from outside that particular class. So this should fail in compilation, I'm not sure. Yeah, if you see std string car is the data type, car double colon color is private within this context. Okay, which means that c1.color, you cannot execute that particular statement because c1 is created outside the scope of the class. So this means that we need to provide some function in order to access it, and that function should be public. If, for example, if print color was private as well, we won't be able to call print color c1.printColor like we did on line number 36. So I hope at this point, like how you can create objects and how you can define the class, that part is clear. Okay, and we will talk a little bit in detail, like you already know what access modifiers are, but we will just extend it a little bit and understand that in more detail. So now there are three types of access modifiers which we are already aware of: public, protected, and private. So now private entities. When I say entities, I mean both functions and the variables which are defined inside the class. So private entities can only be accessed by entities of that class. When we talk about protected, it's a superset of private. It is accessed by all the entities of the class, plus it can be accessed by entities of child class. Now this will become more clear in inheritance, so no need to worry if you don't understand it right now. Just remembering the definition in some sorts is sufficient at this moment. Now about public, it can be accessed by the entities of that class, plus it can be accessed by entities of the child class, plus, I mean, it's the superset, it can be accessed by anything. Okay, accessed by anyone. So this is the rough definition of access modifiers. And I mean, that was pretty clear in the example that we took over here as well, that we were not able to access the color attribute directly from the main function as it was private. I'm not explaining the protected part over here because there will be a suitable example for that in inheritance as well. Okay, all right. Let me see if there is a specific example for access modifiers. There isn't, because this will become more clear as we take on more concepts of object-oriented programming further in this module. Now, at this moment, it is really important. If you want, you can just rewind this particular video and go through what a class is actually, how crucial are access modifiers in protecting how the data members and the member functions are accessed, and how an object can be defined. Okay. Now let me just tweak the object example to try out some other thing. Can we define a class of data type car with no constructor? Is this possible? Okay, let's try to do that. And let's try to also print the color. Okay. So it says there is no matching function call to car. Okay, so this is the constructor type. If I move back, so this is an explicit constructor that we provided. When you provide an explicit constructor, you need to follow that particular definition. And what we did over here was we defined a constructor with no parameters. Okay, it is expecting a constructor with no parameters for the second example that we tried to do. And it says that there is no such constructor available. But there is a potential candidate which takes in three parameters of type integer, string, and string. You can use that, and it also adds an expectation that candidate expects 3 arguments and 0 are provided. Okay. So that is the definition which we should be following. But we will come across some examples in future in which we won't provide this constructor explicitly, and it will define some object for it. We can tweak it over here as well. Let's say we comment this particular constructor. So now we also comment the C1 part. This should compile. This does compile. But note over here that none of the attributes, none of the data members have been assigned any values. So whatever the strings are, those will be empty strings. So now if you notice, it prints the statement which is there in that particular print color function. It says the car's color is, and there is an empty string over there because we have not defined it. So if you don't define any particular constructor, you can create the object using this particular syntax, like car C1. You don't need to create empty brackets. Like you can create empty brackets as well, but that, like, both of them are equivalent. Okay, so that doesn't make sense. Like lesser code is better code if it is readable. So in this way also, if there is no constructor provided, you can create an object. So I think we observed both the ways of creating an object using a default constructor, which was the second object that we defined, and the first object was using an explicit constructor. Now let's come to the 4 main pillars of object-oriented programming, and we will start with encapsulation. So encapsulation has a very close association with the access modifiers. Okay, first of all, we'll understand what is the technical definition for encapsulation. Access modifiers. Now, what does encapsulation mean? It means that we want to protect the data. We want a particular way of exposing some data members to the public, and some we want to hide away from them. So we will use private access modifiers for the data members which we don't want to publicly expose. So if you notice the example that we took for the car class, in that we defined the data members as private because we didn't want them to be accessed from outside. Now, this was not a very good example to show the importance of encapsulation, but imagine there is a bank account data type. Okay, the class is bank account. And let's say there is a data member balance inside it. Okay, and it is public. Int balance. It can be a double, but let's say it's integer. Int balance. Now anyone can access this data member from outside the class, whatever, like whoever the user of this particular class is, and they can update it. Let's say my balance was 10 rupees. And they can tweak it to 100, or they can make it 0 as well, and they can make it negative. There is no control over how this data member can be accessed by others. So this is where encapsulation comes into place. it makes those particular, like whichever data members are critical, it will make them private or protected based on how we want to access it. It will be protected if we want them to be accessed by the child class. It should be private if we don't want them to be accessed by everyone and only by the members or entities of that particular class. So this should become private if we want to protect it, like if we want to hide it from the public. And there will be some public interfaces exposed in the form of member functions. Okay, so it can be like credit. For example, credit is a suitable operation for which the balance can be increased. Okay, so it can be int amount, and in this way you can update your balance. Okay, and similar function can be created for debit as well, in which we will deduct the particular amount from the balance. But we don't want any ad hoc access of the balance data member by anyone outside the class. So in this way, this is what encapsulation actually means. It tries to control what data member can be accessed by the public and what data member should be hidden from the public, and then it exposes private interfaces for access or any processing on that particular data member. So a typical example for encapsulation would be creating some getters and setters. Now what does a getter do? A getter tries to access. If we want to read that particular, like read the value stored inside that data member, we can use that getter. And if we want the public to be able to set some ad hoc value to that particular data member, we can use a setter. And we can define for what data members we want to create a getter and for what data members we want to create a setter. For example, someone might want to check their own balance. Okay, so creating a getter for them is a very intuitive thing to do in terms of a bank account class. But for example, no one should be able to directly update their balance on their own. So creating a setter for that particular data member is not a wise thing to do. Okay, so we won't expose any such interface to directly update that particular data member. Now let's take a look at the code for encapsulation to understand this in more detail. So if you check the code over here, so we have created a getter and setter. Now this getter and setter is just a technical term, like you can use any name for it. Over here I have used get color and set color because color is a very intuitive thing. Someone wants to get their car repainted with some other color of their choice. That set color option is not damaging to that particular object, and get color is also intuitive, that someone might just want to know the color of their particular car. So we have exposed getter and setter over here. Now we might also want to get speed for something. Okay, but set speed is not a very intuitive function to add over here. Okay, because whenever you are accelerating or deaccelerating, at that moment your speed should change. We should not allow any random access to the speed variable by using a setter. And we have also created some public interfaces to change the is on data member, like we have provided turn on and turn off if we want to switch on the car and switch off the car. So let's try out the example. What the example does over here is it creates a object C1 of type car, and it's the previous example itself. In line 44, it tries to print the color of the car, and we are doing it in two ways. One is we are using the public interface provided to print color of the car, and other one is we are directly trying to access it using c1.getColor. Remember, we tried to access it using c1.color in the previous example, but it didn't work out because color was a private member. In this case, we have exposed the public interface to provide color. So we still cannot use c1.color, but instead we can use c1.getColor because that is how the creator or author of this class has provided the interfaces for the user to act with them. And in the next line, we are trying to update the color by using a setter, and then we are again printing both the types of colors. Like we are trying to print the same color in two different types, one using the public print color method and one using the get color public getter that we have defined. Now we'll compile it. It works fine. And if you notice, the output is as we are expecting. When we call the setter, it will update the color from white to red. And when we are trying to print the color, it knows that the color has been updated. That effect has been propagated to that particular object, and it is visible from the last two lines that have been printed on the terminal. Okay, so now this is what encapsulation basically is. There is no rocket science. You just try to control what data members you want to give access to the public code, and how you want to give access to it. Some code you don't want setters, some code you don't want getters and setters. It completely depends on your use case. In bank account, I would not mind having a getter for the balance, but having a setter for the balance is quite damaging for that particular object. Moving on to the second concept, it is abstraction. Okay, now what is abstraction? I think I kind of talked about it when we were talking about functions. I talked how the implementation is abstracted when we use functions. So what abstraction means, we want to take away the complexity from the user. Okay, the person who is using that particular object, we want to take away the complexity. So we want to hide implementation and hide complexity. Now, for example, if I'm driving a car, okay, I know that turning on the key will actually turn on the engine, like I need to press the clutch and then turn on the key to start the car. But I actually don't know what goes behind the scene, like how the piston rotates, how the fuel is injected into the engine, how the combustion happens and all of that stuff. Okay, it is abstracted out for me. I just know that I need to press the clutch and turn the key in order to start the car. So that is what abstraction also actually means. It provides a contract to you that this is the name of the function. These are the input parameters which are expected of this particular data type, and you can expect an output of this data type. So that contract is set up for you, and you need to be aware about what the name is, what the input is, and what the expected output is. You don't need to know how the input is processed to give you the output. For example, like in this code, I can add the functionality for refueling, and for that obviously I will need to add some more data members like fuel capacity and whatever the current fuel level is and so on. So we will add two private members, fuel. So we will have something known as fuel capacity as a private data member, and we will also have current fuel level. Okay, we can just write fuel level. And we can define a public function. Now both of these should be private because we don't want anyone to be able to update it or get it directly. We want to encapsulate these data members. And public, we can just have, we don't want any output from this, void refuel. And we can just like mention what amount of fuel we want to add, like in liters. So int added fuel probably. Okay, and we can do whatever the fuel level is plus added fuel, and this will become my new fuel level. So we can just do plus equal to added fuel. Now a catch over here is it can exceed the fuel capacity. So maybe you want to add an if condition on top of it to ensure that whenever we are adding fuel, it doesn't exceed the fuel capacity. And if it does, then we only add, like we don't need to add all the fuel that is provided. We will just add a subset of it. Now, you might be wondering that this looks similar to encapsulation. In that also we're trying to create some functions which were public interfaces to control like how the access was provided to the private entities, and abstraction also looks something similar. In both of them, we don't know what the actual implementation is, but we are having access to that particular member function. But the intention is different. Like both of these are concepts, or both of these are provisions which are important to make a language object-oriented programming. And the intention, what's the intention of abstraction? It's to hide the complexity. It makes life easier for the users of that object. Okay. Abstraction makes life easier for users of object. And what does encapsulation do then? Now, encapsulation makes life easier for the author of the object, because they are in control of what can be accessed by the normal user and what cannot be accessed. So it is encapsulation, you can consider it as a protection feature, a security feature, and abstraction is a feature which makes things easier for the user of that object. So this makes life easier for the author. Now let me just make a distinction over what the user is and what the author is. Author is the person who is creating that class. Okay. So in case of bank account class, whoever is the person who wrote that particular system becomes the author of that class, and it makes life easier for them because they know for sure that they have not created any setter and the balance attribute is private. Okay. They are in a relief that no one can randomly update the balance. Whereas, for example, if I want to do any credit or debit, I am at ease at this moment that I know that my whatever amount I am crediting, it is going to get reflected into the balance somehow. I don't know what is happening behind the scenes, but I as a user am relieved that there are some interfaces for me to debit the money, withdraw the money, to make a fund transfer or anything, and it makes life simpler for me. So the intention is the main difference between abstraction and encapsulation. Now going over some of the crucial concepts now. I mean, encapsulation and abstraction are two crucial concepts, but these are more technically complex as compared to the previous both of them. First of all, let's take a look at the code that we have created so that we don't miss out on any concept. Okay. All right. I think we can make changes to encapsulation to just have a look what is happening. Okay. We can add both, like whatever I mentioned over here, we can add both the attributes fuel capacity and fuel level. And just then we can have a look how we can access it. Now let's expose a public method. Int added fuel, and we want to check first of all if current fuel level plus added fuel is less than or equal to fuel capacity. If yes, then we will add it fuel level plus equal to added fuel. If not, okay, else what will happen? In this case, whatever the added fuel is, if we add that fuel to the current fuel level, it will exceed the fuel capacity. So what we can do is fuel level is equal to fuel capacity because we know this is going to be greater than the fuel capacity now. So this is how we can just create a function and then anyone can use it from outside. So by default, the fuel level will be 0 and fuel capacity will also be 0. So probably in the constructor, we can have integer fuel capacity and then we can also assign it fuel capacity equals to FC, which is short for fuel capacity. And then in the constructor, we can just change it, like let it be 45 liters. I'm not sure what's the typical fuel capacity. So 45 liters probably. And then we can use, like you can just copy paste the code is visible to you. And you can then try to access the refuel method with the levels of added fuel such that you can like pass 50 as the added fuel, which would probably exceed the fuel capacity. And then when you check the current fuel level, okay, you can just add a getter for this as well, because someone might want to check their fuel level if they want to refuel it or not. Okay, so get fuel is a very valid getter in this case. It's intuitive. We don't need to pass any parameter to it. We just need to return fuel level. Okay. So this example covers both encapsulation as well as abstraction. We don't know how exactly refueling is happening and the user is not worried about it. They can pass 50, they can pass 60, they can pass 30 as well. And they will be assured that whatever is the actual amount of fuel that should be added will be added to that particular car. So this is how like you can just modify your code and try out abstraction in your systems. Now let's move on to polymorphism, which I was talking about. Now, an English lecture for all of you. I'm not sure if it's an English lecture or Latin lecture, but polymorphism is created out of two words, which is poly, which means many or multiple, and morph means faces, okay, or forms in this case. So polymorphism stands for many forms. Now, if someone were to ask me that, hey, Anshul, define me what polymorphism is in a single line, then this is going to be my definition. A function with the same name which may or may not have different types of parameters, input parameters, and may or may not have the same type of output parameters is what is polymorphism. Now, I am sure this definition is not like intuitive to understand. So I will explain it in detail, like what actually polymorphism is. But just to put into words, it is one function name and this can have different input, both numbers and types. Okay, the number of inputs can also be different, like there can be 2 parameters, there can be 1 parameter or 3 parameter. Both number of inputs and data types of input. Now it can also have different output types. Okay. Now there is one data type that we didn't discuss in the first 2 modules, and now I think that's the right time to talk about it. So if you notice over here, I have been using void data type a lot, but I have not explained it. Okay. So void means empty data type, first of all, which means it's empty. I mean, there is nothing, we are not returning an integer, we are not returning a string or a boolean or anything at all. There is no expected output for that particular function. There is just some processing happening. Either it can be like updating some private data member of that particular class, of that particular object, or it can be printing something as simple as what we are doing over here. We are printing the car's color. Okay, so we don't need to return anything. It just says print color and we are printing the color of the car. So this is an empty data type where we don't expect the function to return anything. So this is what polymorphism basically would mean, but there are multiple type of polymorphisms and definitions would change for each one of them. But at the core, this principle is same. The name of the function is the same, but you can expect same or different input. Okay, but like for example, let's say there is add int comma int. Okay, and the return type is an integer. All right. And now if there is another function with the same name and the same input and output types, then this is not polymorphism. This is just confusion. Okay. So polymorphism needs to have something different. It can have a different output type. It can have different number of input types or different input data types as well. So there needs to be something different. There needs to be multiple forms in order for it to actually be a polymorphism concept. And a good example of that would be, for example, there is an add function. Like above you saw an add function which took in 2 integer data types. We can also have 3 integers which can give addition of all the 3 integers and return an integer. All right. And we can also take in 2 strings and then concatenate it. If you remember, there was a plus operator which we were using, right? And for integers, it was performing mathematical addition of both the members. And for strings, it was not doing a mathematical addition. It was doing a concatenation of both the strings. So it was one function, one operator, and it was for different data types. It was doing different things. Okay. Now, I think the core of what polymorphism is clear at this moment. But I want to take some time to explain what compile time polymorphism is and what runtime polymorphism is. Okay. And then there are few other parts of what polymorphism can be. What we discussed over here was compile time polymorphism. Okay. Now let me just get rid of this and I will explain what compile time and runtime means over here. So first of all, whenever there is a function definition which defines what the input data types are, what the output data type is, what is the name of the function, and what is the code block inside the function. Okay, that is known as a function definition. Okay, let me just change it to declaration, because for compile time and runtime, declaration is sufficient. We don't need complete definition. So just for a revision, declaration means the output data type, name of the function, followed by the data type of the integers. Okay, this is sufficient for creating a declaration. And then there will be function usage as well. Okay, which means whenever we call that particular function, usage, and this would be something like function name, whatever it is, followed by 5,6. This is just an example. Okay, and we will just have int output is equal to fname 5,6. So this is a function usage and this is a function declaration. So what compile time polymorphism does is, let's say there are two different declarations. Let's say this is a void declaration and there is another, let's say this is add. Okay, we will add some function name to it, and there are 3 parameters this time. Okay, so these are 2 different declarations that we are provided. Now for example, in the function usage, if I just replace fname with add, and if I have another function usage where I try to add 3 numbers, 4, 5 and 6, let's say. So this is an example of compile time polymorphism, wherein while the compilation happens, the compiler tries to do an early binding of the function call and the function declaration. So it knows that this function call should be mapped to the function declaration on the top, and the second function call should be mapped to the second declaration that we have provided. So at the compilation type, we know that whenever that particular statement is executed, okay, let this be line number 1 and let this be line number 2. So at the time of compilation, we know that whenever line 1 is executed, it should be calling the first function, and whenever line 2 is executed, it should be calling the second function. Now in runtime polymorphism, the compiler doesn't define which function needs to be called. The decision is taken at the runtime. I'm not covering that in detail at the moment, but we are going to spend some time about runtime polymorphism after I talk about inheritance, because that becomes crucial to understand runtime polymorphism. Okay, so now if I wanted to talk about function overloading, so we already took that example. What function overloading means, same function name, function name, now it can have different number of input or different input data types. Or, now these are all ors. Okay, I mean it can be both of them or it can be any of them. But this is mandatory, like one of them is mandatory for it to be a function overloading, or it can be different output type. Okay, so now this is the condition for function to be called overloaded, and this happens at the runtime. This happens at the compile time, my bad. This is a compile time polymorphism. Now we have already taken a look at an example of function overloading, which was the add function. So now as we can see that the compilation is successful, we can just try to execute the code, and probably it would take the 4th definition as double, and the output for that should be 3.4. Okay, so it knows what function definition it should be binding to. And for example, instead of 2.4, if it was 2 itself, then it becomes the first function call itself. So there is no meaning of replicating that thing. Now if you notice, it returns 3, 6 and 3.7. So it does as expected. It tries to call 3 different functions for 3 different types of bindings. Let me just print over here so that we know these are indeed three different functions. Add two numbers. We can mention add three numbers over there. And then here we can mention add two doubles or decimal numbers. That would be the right thing to do. Now let's try to call this once again and see what's the output. So if you notice, all the three different types of functions are called for all the three different types of definitions and function call bindings. So this happens at a compile time. Okay. Now I would try to prove this to you that this happens at a compile time, but then it would mean I had to read the compiled code, which neither you or neither me can read it because it's an assembly level code. But yeah, I think you need to trust me on this, that the function call happens because it has been early binded and it happens at the compilation time. So now this was a typical example of function overloading. Now let's take a look at another type of compile time polymorphism, which is operator overloading. And we have also talked about it in the past when we talked about the addition operator. Okay. Now addition operator, it can take two integers and return a mathematical output. Okay. It can also take two strings. And in this case, it gives me a concatenation, which is it combines both the string. Now, can you think of an example where we can use this operator overloading? Okay. Now since this is an operator, this is known as operator overloading because it has different definition of functions in a sense, but this is not exactly a function and hence we call it operator overloading. In the previous example, what we were doing was we were having different definitions, like there were different forms of the function and hence we are calling it function overloading. In this, it is different forms of the operator. Okay. So now let's look at the way how we can overload an operator in our class. So let's just open the operator overloading code. Now if you notice, I have defined a class for complex numbers and I have two private attributes, real and imaginary. Like a complex number has two parts to it. And there is a public constructor of it which takes in the real part as well as the imaginary part and assigns real and imaginary to it. Now the syntax of operator overloading. So this is the class name, like whatever data type we want to overload. First of all, it need not be a class name. It is the overloaded data type followed by whatever the symbol of the operator is. Okay, and then we need to take the same data type over here. Let me just get rid of the example. Okay, so then we pass this constant. Now there is const over here. It means that you cannot change the data type which has been passed. Okay. So we are passing the same data type which we want to overload for the plus operator. So for string, it can be something like this: string plus const string and object. I mean this you can name anything. I have just mentioned it object. Okay, and then in the function what you can do is you can just try to perform addition of both the strings, like whatever the attributes are, whatever the characters are, you can add the characters of object to the object of the particular string. Now over here what we are doing is we are using a complex data type. It's not complex by nature, it's the complex numbers. So the definition of operator overloading is like whatever it's highlighted over here. So what we want to do is we want to perform addition of two complex numbers. So we have access to real and imaginary for this particular object, and we take in another complex number in the form of obj variable name. Like another complex number is taken in this particular function through the obj variable name, and then we try to create new real numbers and like new real part and new imaginary part for that particular complex number. And then we return this complex number, which is evident from the return data type of the operator overloading function. Now I am just having a public interface for print complex just to understand what the complex number is. And in the int main function, what we are trying to do, we are trying to create two complex number objects. They have the real and imaginary part 1 and 2 and 3 and 4 respectively. And we are trying to perform an addition. There is no explicit, like we are not using the explicit definition of addition over here. Like in string, there is an explicit definition for string addition, which is concatenation. Here we are using the user defined operator overloading for the plus sign, for the plus operator. And then we'll try to print the complex number C3. Okay. Let's just try to compile this code and run it. So I should be printing the previous complex numbers as well to understand what they were. Let's try to compile this again and run this again. So if you notice, the first two input complex numbers were 1 plus iota 2 and the second complex number was 3 plus iota 4. And the output of the real part 1 plus 3 became 4 and 2 iota plus 4 iota, it became 6 iota. Okay, so this is the addition of complex numbers. This is how you can overload an operator and make it two different things than what it was previously intended to. All right. Similarly, like a take home assignment for you in this case can be to create an operator overloading for the subtraction sign, and you can try to subtract one complex from the other complex number. So this is what operator overloading means. And now before moving to the function overriding part, which is part of, first of all, this is runtime polymorphism, just to give you an hint of it. Runtime polymorphism. And virtual functions is also an example on top of function overriding. Virtual functions, this is technical jargon at the moment, but I want to cover inheritance before covering the runtime polymorphism. Otherwise, it will become a bouncer for all of us. Now, let's take a look at inheritance first. What does inheritance mean? Okay. Now, this is similar to the inheritance that we have seen in our real lives. Like whenever a baby is born, the people are passing judgments and making comments that, hey, the nose of this baby is looking like his or her father, and like from the maternal side, someone would pass a comment that no, it's not looking like the father, it's looking like the mother, and so on. So in the same way, in the object-oriented programming paradigm also, one class can be inherited from the other class. Let's use the words parent class and child class. So there is a parent class which has some variables, which is the data members, and also has some functions. Now, when this is inherited by a child class, okay, I will show the syntax of inheritance as well. But when we inherit one class from the other class, the attributes of the parent class are passed to the child class, not all of them. I will explain that part as well. If you remember, private attributes are not passed, private functions are not passed to the child class. Only the public and protected ones will be passed, if you remember the definition of the access modifiers. So there will be a subset of the parent class entities which will be passed on to the child class, and the child class can then also add their own data members and member functions. Okay, so the child class will have access to public and protected entities, and they can add their own as well. Like they can add their own data members, they can add their own member functions as well, and they can add of any access modifier, like they can add public, protected, private as they want to. And the definition of public, protected and private here remains the same. Add their own entities. Now there are different types of inheritance as well. Like we will take a look at the example first before I explain what are the different types of inheritance, and like we will just try and play around with private, public and protected variables so that we can see that this was indeed the case, whatever I told. Now, like you may interchangeably hear me or anyone using following terms to talk about inheritance. Parent-child is a very common technical terminology for inheritance. parent child, superclass and subclass, and base class and derived class. Okay, I may be using any of these following pairs and all of them mean the same thing, that the child class is inherited from the parent, or the subclass is inherited from the superclass, or the derived class is inherited from the base class. So before that, let's take a look at the inheritance code. Okay, so if you notice, we are using vehicle as the parent class, which earlier used to be car, and we are inheriting the car class from the vehicle class. Now there is a constructor for vehicle class and we only have one attribute, which is a private attribute is on. Okay, which means that is on attribute is not passed to the child class, but all the public member functions like turn on, turn off, and boolean is on, all three of them would be passed, as well as the constructor of the vehicle class. So all these member functions will be passed and the child class would have access to them, and the child class can update it. If you notice in the child class car, it has added one more attribute, which is int wheels. It won't have access to the attribute is on directly. Okay. And then in the constructor, we are just initializing it to 4. We are also calling the constructor of the vehicle so that is on is initialized to false. And then we can use get wheels and some of those. Like this is the getter for the wheels attribute because wheels is a private entity. Now let's just try to compile this code and see what is actually happening. So if you notice, it has printed 0, 1, I'm not sure what it is, and it says car has 4 wheels. So now let me just add some message so that it is clear. Is on. And I will copy paste this message in the next one as well. And let's just run this code once again. So if you see in the first output is on is false, in the second output is on is true. And if you notice what happened in between them was we used c.turn_on. Now we could not directly update c.is_on equals to true because it is a private entity. We can just comment this statement and try it out. c.is_on is equal to true. Let's try this thing. Now the compiler should throw me an error. And it does. It says that is on is private within its context. It also suggests me that you can access this particular attribute using is on function. Okay, which we have used in the output statements. But that is not what we want to do. So we can probably convert the private attribute to protected. So if you remember, protected attributes can be accessed by the child class. So now this should compile. So if you notice, it is still throwing me this error. It says that is on is protected within this context. Now, why did it throw this particular error? It is because I'm trying to access the is on data member from outside the class. I can access it from within the child class, but I still cannot access it publicly. Okay, so I can just add another method to it. Okay, turn child class on. Okay, and this I can use. Now in this case I should have access to this. I should have access to the is on protected data member because I have put it protected right now. We can also see that if it is changed from protected to private, it will again throw me an error. So let's just, instead of actually updating it from public, we can call c dot, what's the name, turn child class on. Okay, now if we try to compile it, hoping it compiles this time, and it does, and we can see it gives us the same output as it was expected. Now if I convert the protected data member to private, this should throw me an error. I can just remove this as well because by default it is private. Now it says that is on is private within this context and we cannot call it in the member function turn child class on. So this will fail, and we can in this case we can use the turn on method, which is publicly mentioned in vehicle class and which will be inherited by the child class car as well. So I think this was a good example to understand how access modifiers play a crucial role in inheritance and what is the importance of protected access modifier in this case. Now, as I told you earlier, there are different types of inheritance, and the inheritance that you saw in the code right now, it's a public inheritance, which is demonstrated on line 26. Okay. So the syntax for this is class child. Okay, this is an example. This is not a syntax, class child, followed by a colon, and then whatever the access modifier is for the inheritance modifier. Okay, this is not like, this is the access modifier for inheritance. This is different from the access modifier of the entities of the parent class. Now everything will make sense in a short amount of time. And this will be followed by the parent class and followed by the definition of whatever the child class is. Now, whenever we inherit a parent class publicly, it means that, okay, I think I should make a table as well, but let me remove this first so that I have space to talk about what I want to. So whenever we inherit a parent class publicly, okay, public inheritance, which is what we did in this example in the code, public inheritance, and by default the inheritance is public. Okay, if we didn't use the word public, it was supposed to be a public inheritance only, contrary to private being the default access modifier for the data members and the member functions. So in case of public inheritance, in the parent class, it is public, and in the child class, the entities remain public. And this is sort of an identity thing, like protected remains protected in child class as well. And private elements of private elements of the parent class, we cannot access it. Okay, not accessible, no access. Okay, so in the child class, they are followed as it is. The public attributes remain public in the child class as well. And the protected attributes in the parent class remain the protected attributes in the child class. Now, if it is a protected inheritance, okay, then in the parent, if it is public, it becomes protected in the child class. If it is a protected attribute in the parent class, it remains a protected attribute in the child class as well. And private attribute, we cannot access it in the child class in any condition. Okay. So now the last one remaining is a private inheritance. In private inheritance, everything becomes private, like whatever, like public or protected attributes in the parent class become private. And we still can't access the private attributes of the parent class. That is the definition. Now we can just take a look at this table so that it makes sense. So this is the inheritance type. And this is the access modifier of parent attributes. Okay, so this is exactly what I told. If it is a public inheritance, then public of parent remains public of child, and protected of parent remains protected of child. Private, we can't have access in any of the types of inheritance. So this is sort of redundant, like we don't need to mention it in the table at all. In case of protected, both public and protected becomes protected attributes, and in case of private inheritance, both of them become private attributes. Now let me just convert this public class to protected, and you will notice that if I try to access get wheels, it will throw me an error that the public over here in line 50, okay, we are trying to access it in publicly. but it will become a protected. Okay, get wheels is overridden, so I think c dot turn on will be protected, so that will be throwing an error. C dot get wheels remains public because it is an add-on attribute, add-on function that we have added to this particular car class. If you notice, whatever the functions were in the vehicle class, they will become from public, they will turn protected, and we won't have access to it on line 47. So if we try to compile it, on line 47, it throws me an error that vehicle is not accessible base of car. Okay. This says that is on is mentioned in the vehicle class and it is inaccessible from this context. But now if I convert this from protected to public, or if I just remove it, the default is public. Okay, I'm assuming default is private in this case as well, so I explicitly need to mention public. All right. Okay, so just to give an update, the default type of inheritance is private, and you can just play around with different types of inheritance type and different types of attributes, different access modifiers of the base class, and you can just try it out what all you can access from which class or from public you can access and what is not accessible. So now I think we have talked sufficient things in inheritance, and it is a good time for us to go back to our remaining runtime polymorphism. So what is function overriding? Now this has a very close relation with inheritance. Let's say we have same function definitions in both child class and the parent class. Okay. Let me just open an example so that understanding it from a good example is better. So if you check the code over here, there is a parent class and there is a child class which publicly inherits the parent class. Both of them have public member functions print, but both of them have different definitions of the classes. I mean, in one of them we are printing parent class, and in the child class, which is inherited from the parent class, we are printing child class itself. So parent class and child class, it has same declaration, but different definitions. Okay. So in this case, the compiler doesn't take a call which function should be called. It is at runtime decided, like the resolution happens at runtime, and this is also known as dynamic binding or late binding. Okay. Dynamic or late binding about what function should actually be called. So if you notice over here, we are creating a child object in line 22, followed by calling the print function in line 23 and explicitly calling the print function of parent class in line 24. So in line 24, this is compile time decoding, like compile time. At the compile time we decide, because it is explicitly mentioned that the print function of parent class needs to be called. But in line 23, this is late binding because there is no explicit mention of what function should be called. And at the runtime, it will be decided that the print function of the child class should be called because of its data type. So let's just compile this thing. And if we run it, if you see, the first output is child class and the second output is parent class. So if you notice, in the beginning, we are trying to print c.print, which is what, like, the statement inside c.print is child class, and the statement inside the print function of the parent class is parent class. So when we are explicitly mentioning that, hey, call the print function from the parent class only, at that time only, it will decide that, okay, the statement, like the function call, should be done from the parent class, from the definition of the parent class. So this is what function overriding is. Like the declaration is same. If we compare it with overloading, in that the declaration was supposed to be different. Okay. The definition could or could not be same. The definition was not in contention at that time. And function overriding is possible only in inherited classes. So in this case, we would say that the print function in child class is overriding the print function in the parent class. And now we come to a crucial part, which is virtual functions. And by far, this is like the most complicated thing that I would be talking about in this particular module. Okay. Now abstract classes and pure virtual function and everything is much more complicated than that. But for the scope of C++ basics in object-oriented programming paradigm, we are not going to cover that part. But that will become more clear in another video, which I will be making on a C++ project of low-level design. In that, I will be talking about it. But in this, let's restrict only to the virtual functions. So now, first of all, virtual functions are overridden functions. That is the first definition of it. And the keyword which we use to make okay, let me take it step by step. A virtual function is an overridden function. Okay, and how do we define a function as virtual? In the parent class, we add the keyword virtual in front of the function definition. So let us take an example to understand that. And this is also an example of runtime polymorphism, as I previously mentioned. So let's just open the code for virtual functions. And if you notice, like it's a similar kind of a definition. We are having a parent class, child class inherits from the parent class, and it is a public inheritance. Now there are two methods, print and display, in the parent class, both of which are overridden in the child class. Both of them have different definitions, but the same declaration, like the input parameters and the output data types, everything is same. But if you notice on line 7, the print function in the parent class is marked as virtual. Okay. So when we override it, there is an explicit message transferred to the compiler that, hey, don't decide the binding at the compile time. It should be done at the runtime. So virtual keyword tells the compiler to do late binding. And runtime polymorphism can be achieved by using the pointer, base class pointer. Okay. Now I will explain this by using the example, but just for the purpose of a definition, runtime polymorphism can be achieved by using the base class pointer. Now a base class pointer can point to both a base class object or a child class object. Okay, and a call is taken at the runtime. If it is a base class pointer, then what function we should be calling based on the content which the pointer is pointing to. Okay, how is it decided? Based on the content pointed by the base class pointer. Which function should be called? The one in the parent class or the one in which is overriding in the child class from the parent class? Which function should be called? Okay, so now this late binding is done. Now if we carefully look at the example, what we have done in the int main function, we are creating a parent pointer with variable name p and a child object which is defined with the variable name c. Now in the next line, what we are doing is p equals to c address of c. Okay. Now what is happening? We are pointing P to the location of the child object C, which means that even though it is a base class pointer, the object which it points to is actually of the child class. Okay. And this is how like we can achieve runtime polymorphism, like by using the reference of the child class. When we point the base class pointer to the reference of the child class, it will lead us, it can help us achieve runtime polymorphism. Okay. Base pointer to reference of child object. Now, this is just a quiz for you. I'm not expecting you to answer it correctly. But when we call P arrow print and display. Now, first of all, whenever we are using pointer, the elements which it points to, we can access them by using a arrow instead of a dot, which we were using for normal objects. Okay. So now P print and P display, what should be happening behind the scenes? Let's first print it and then I will talk about why it actually happened that particular way. Now let me just get rid of this, or we have an empty page. We should be having an empty page, yeah. So this is not about inheritance. Now the first thing which has been printed is child class. And the second output was parent displayed. Okay, let's also take a look at what were the commands for this. P arrow print and P arrow display. Now just to add some details, print is marked virtual in the parent, which means that it tells the compiler that, hey, don't do early binding of this particular function call. We will decide at the runtime what should actually be called. So when in line 32, if you notice, the content of the base class pointer is actually child object. Okay, so based on that late binding, whenever we call P arrow print, okay, when this call is happening, we will see that P actually contains data of child. So child, the print defined in child class should be called, and hence child class is printed. Okay. Now when we are processing P.display, okay, this is an early binding. It says that since the data type of P is of parent, we will actually be using the member function which is defined in the parent class, and hence parent display is used. Okay, parent display is printed. Now that is the reason the first statement is late binding, because we added virtual keyword in front of it and print is marked as a virtual function. And the second function call is early binding. It was decided during compilation only that the display function of the parent class needs to be called based on the data type of the pointer. Now this is how you can use virtual functions to actually invoke or use runtime polymorphism. And we will just take the last example, which is like, I think it summarizes everything that we covered in this particular module. So if you notice, let me just get, I think this is important. This I can get rid of because there is already an image for this at the end of the slides. Okay. So now there is a base class and there is a derived class. Okay. There is a base class and there is a derived class. And both of them don't have any data members. They have member functions present in both of them. Some of them are marked virtual in the parent and some of them are not marked. Okay, so let's talk about base class. There is an f1 function. Corresponding to it, there is an f1 function derived as well, which is overridden but not virtual. Okay, this is not virtual. I can remove this. All right. Now there is f2 defined in base, which is virtual. And same goes for, now these are empty parameters. Same goes for f3 as well, which is also virtual with no parameters, and same for f4 as well, which is also virtual. Now if I compare it with derived class, f2 is overridden, and if you notice, f2 is virtual in the base class. So if we were to access f2 of the child class using the pointer of the base class, of the derived class using the pointer of the base class, then f2 in the derived class should have been invoked. We will check the output. Okay, so this is overridden. f3 does not exist. So if we were trying to call f3, the one in the base class should have been invoked. And there is f4 with a parameter, int x. Okay, now this is not overridden. We would not call it overridden because it doesn't have the same declaration. Not overridden. So now let's just try to run it. What we are doing is we are using a base pointer b. We are pointing it to the object created of derived data type, and then we are trying to invoke all the 4 functions from the base pointer itself. Now I have compiled it. On running it, if you notice the output, let me just type the write the output as well. The output is base 1 derived 2, base 3 and base 4. Now what were the commands used for it? b.f1, b arrow f1, b arrow f2, b arrow f3 and b arrow f4. Now if you notice, like this has a data type of base class, and since it is overridden but not virtual, the decision will be taken based on the data type of the pointer itself, and hence base 1 is printed. Okay, now in the second function call, it is overridden but the parent function is marked as virtual, and since the base pointer points to the object of child class, runtime polymorphism happens, and the decision is taken to call the f2 which is defined in the derived class, because the pointer of the base class points to the object of the derived class. Now it might sound confusing, so you might want to just rewind it and make this really slow, like 0.5 or 0.75, to actually understand what I just spoke right now. And if you notice f3 is not defined in the derived class at all, so we will be calling the f3 which is defined in base class. And for f4, there is like, this is not over, f4 in derived class is not overriding f4 in the base class, so it is not runtime polymorphism. These are two different function definitions, function declarations, and hence since we are calling the one with empty parameters, the decision will be taken that we are calling f4 based on the data type of the pointer. Now I just have another exercise wherein we try to call f4 from the base pointer with an integer input to it. Now this won't compile. This won't compile because it says no matching function for call to base of f4 integer. Now if you explicitly notice, the error says there is no definition for this. Now why does it say this when we are actually having another definition in the derived class with an integer parameter to it? If you notice, this is not overriding. The function definition in the derived class is not overriding, and hence no runtime polymorphism actually happen, because it needs to have a combination of both virtual keyword in front of the base function, and we also need to override it using the same definition of the virtual function in the base class. So hence, since this is not overriding, this will not have runtime polymorphism, and the decision will be taken based on the data type of the base class pointer, which is base object itself, and hence it will not find any function declaration with an integer parameter to it for f4, and hence it throws me that error. But if I had d.f4, this will run, okay, because the data type is different and this gets compiled, which earlier was throwing me an error. And if you notice the output, it says derived 4 because there is a matching definition for it. So in this class, we checked about different combinations of virtual and overriding functions and whether this means runtime polymorphism or not. So I think this was the most difficult piece to understand because there was too much confusing things which I was talking. So try to rewind it, try to run it on slow, and then try to replicate it again and understand why a particular thing is happening. Whether it's a runtime polymorphism or not, check the definition of runtime polymorphism which I said. The function definition in the base class should be marked as virtual, and we should be invoking it from a base class pointer which is pointing to the object of child class. So this is what I actually wanted to cover as a part of object-oriented programming paradigm in C++, and I really hope that you watch this video multiple times to comprehensively understand what I just said, and then you try to replicate the function that I have written and then try to do some amazing things with these concepts. So that's it for this particular module. So what are we actually going to design in this video? We are going to cover a vehicle parking system. So for example, whenever I used to go to movie theaters, malls and all of those places where parking used to be a headache, right? The security person would tell me turn left, turn right, and then there was no end where to actually park the car. So this used to get very frustrating, and I was like, why can't they develop an algorithm which decides what are the empty spaces and tells the user that, okay, go and park in the grid GD or G1 or G2 or whatever the cell number is, right? So that is the main motivation behind designing this system. Obviously, we are not going to take it in depth and extend it to a full-fledged product. We are going to decide what classes we are going to use, what will be the attributes and the functions present in those classes, and then how they will interact with each other to create a bare bone minimum viable product which someone can use for a parking system and maybe extend it to a full-fledged product in the future. So we are going to use C++ as the programming language for this. And before that, I think this should be a valid confusion among some of the viewers that, okay, what is the difference between low level design and high level design, right? Low level design versus high level design. So this a decent understanding of what are the distinguishing features is important. Okay, we have covered a lot of high-level system design videos about, Uber and then hotel reservation system, Tinder, Twitter, and so on. So a distinguishing part of those system design topics is that we look at the system from a very high level, as in it's an airplane view wherein we check what services are there, what systems are there, what are the subsystems present in them, what subsystems interact with each other, and so on. But low level design is more like a bird's view, wherein we get a closer view about how the systems are interacting with each other, what is happening inside a subsystem, and so on. If I wanted to give you a real life analogy, let's take up a car. Okay. So what are some of the systems which are present inside the car? I mean, I'm no automobile expert, but some decent understanding, hopefully I'm right. You can correct me in the comment section if I'm not. Okay. So there will be a fuel tank, obviously. Okay, then there will be some power windows. There will be an internal combustion engine. And some more systems interacting with each other. So now in a high level design, what would I be knowing? I would be knowing that there will be some fuel inside the fuel tank, and that fuel will be used to power the engine, It will be passed to the engine, and then it will go through combustion process, and then it will give energy to the car to move ahead. Okay, but what exactly is happening inside the combustion engine? How is the fuel getting combusted? What is the velocity of the fuel? What is the flow of the fuel? How many liters per hours, or whatever the dimension is? Like, the internal happenings are not so visible in a high level design. If I take example of a power window, I just know that this will help me open and shut down and open the windows, but I don't know what mechanism is underlying that particular interface. So all those deeper discussions will happen in a low level system design, wherein we will define how these systems are actually interacting with each other. So in low level design, in-depth discussions of house is happening. Okay, not the home. I'm talking about the how part, like what is actually happening, how it is happening inside that particular system. In-depth discussion of how things are working under the hood. Now in high level design also, if you remember from the system design video of a hotel reservation system, we talked up to some depth about how the booking is happening, but we didn't cover what all logic is going to be followed, how we are going to implement the hotel service and all those different services that we talked about. So you don't expect to have a complete understanding about how the services are going to be functioning when you're actually going to implement it. So when I talk about from a granularity level, it's going to be high level system design followed by low level system design, followed by translating that low level system design into a code. Okay, so that is the granularity level. And things obviously change. I mean, what you might be imagining in a high level system design could be starkly different to a low level system design, because then you will have more understanding about the technical feasibility of those things. So now I think this difference is sufficient enough to convince you that why low level design is important and how different it is from a high level design. So I already talked about the problem statement. So basically what we want is, we want to design a parking system which helps the users know from the beginning that where a vehicle should be parked. They should be facilitated with payment system as well, like what is the amount of parking fee they should be paying, and upon the payment of parking fee, they can vacate the particular parking spot, and new car or any vehicle can be parked in that place. So let me just officially write it over here. So design a vehicle parking system which looks for vacant spots in the parking and facilitates payment of parking fee as well. Payment of parking fee. Now this is our Uber level problem statement, and now we are going to translate this statement and understand what different customer user journeys are there, similar to what we used to do in high level system designs as well. So from those user journeys, we will understand what the functional and non-functional requirements are there. From the functional requirements, we will decide what the class diagram should be. If you remember, in the high level system designs, we talked about an ER diagram, which meant what is the schema of the database, what database we are going to choose, and so on. It used to be entity relationship diagram. In this case, here also we are defining some entities, but these entities are lower level entities, like what the class schema should be, what all attributes should be there, what all member functions should be there, and so on, and how they are going to interact with each other if there are any interactions between them. Okay, so customer user journey, first of all, a vehicle will enter the parking system. Vehicle enters parking. Then next, a vacant space is found for the parking. Then the vehicle goes to that place. I mean, navigation and all of those graphical things we are not assuming over here. We just want to create some interfaces to simulate the parking mechanism. Okay, so the third step should be vehicle parks in that spot. Parks in that spot. Now you might be wondering, what if the entire parking is full? Then we obviously throw an error and tell the vehicle that, hey, no parking is available. Please try after some time, or please wait till a vehicle vacates a spot, or something like that. There can be any sort of an error handling mechanism which you can implement. Then after the vehicle parks in that spot, there will be, like, if you remember in real parking systems, so there is a token given to you which has the start parking time, like the moment in which you entered the parking, and then when you exit the parking, the time is calculated, like how much time were you in the parking, was your car or vehicle parked in the parking, and based on that there is some parking fee which is calculated, and when you pay that fee, after that you are allowed to exit the parking. So then fourth part should be calculation of parking time, and then we can write it in a single user journey, calculation of parking time and parking fee. Then lastly, vehicle leaves the parking. Okay, so this should be very simple enough to convert into functional requirements, first of all. So we need to properly decide what should be the scope of our project, because we are trying to build a minimum viable product. So you would know that in real parkings there are multiple floors, like upper basement, lower basement, and then basement 2 and so on. But right now let's begin with a 2D grid of a parking, and then we can scale it up. So let's start. First of all, there is a 2D parking, and we can capture it using a grid. Capture it using a grid. Now the next functional requirement would be, if I look at my customer user journey, find vacant space, find vacant spot for parking. Occupy the vacant spot from functional requirement 2. And then we will start the calculation of our parking time. Start clock for parking start time. Then we want, like, based on whenever we are leaving the parking, we want, based on whatever the parking start time was, we want to calculate the number of hours or whatever, like minutes or seconds or whatever we want to. In this case, we will prefer hours. So calculate duration of parking, and then calculate parking cost from 5, and then vacate the space for other vehicle. Now these functional requirements will be converted into public interfaces which our classes are going to provide. We will decide what classes we want for this particular system, and then based on these requirements we need to provide suitable interfaces for the users. So now you might be wondering, what are the non-functional requirements over here? Like if we talk about high-level system design, it should be low latency, high concurrency, high availability, and so on. But since this is a low-level system design, we are going to talk in terms of classes. So first of all, we want our classes to be modular so that they are easy to understand and implement. Then we want them to be extensible, because let's say right now, if I choose some classes and I want to add some functionalities in the future, then it should be simple enough. The classes should be extensible enough. Extensible the code should be designed, or the classes should be designed in such a way that they are easy for debugging and testing purposes. So easy for testing and debugging purposes. And I think one requirement which can be, for example, let's say if two cars or two vehicles are coming at the same time, okay, and there is only one spot left, or there are multiple spots as well. We don't want both the vehicles to be parked in the same spot. So we need to be able to handle concurrent request, and in case of C++, we can use multi-threading, but probably this can be this can be a future scope, and it need not be part of our minimum viable product. Okay. So this can be a future goal. Handle concurrency, and this we can do using multi-threading. Like if you are interested in understanding how we can use multi-threading to handle the concurrency issue in this case, let me know in the comments so that we can create a project for the same about multi-threading in C++ as well. So that will be an amazing addition to this particular project as well. So this can be a future goal, and I think this is it. I mean, you can just think about some other non-functional requirements which you want. So modular, extensible, and obviously the classes or the functions which are exposed should be designed in such a way that their time complexity and space complexity are optimized. So that should be one of our primary goals as well. Optimize time and space complexity. And this indirectly translates to latency and better resource utilization. So I think these are good enough non-functional requirements, and we have already decided what functional requirements we want to get started with. So we are good to go. But to those who, like, just to give a quick recap of our object-oriented programming paradigm. So there are 6 dimensions to it. 2 of them are classes and objects, which are the main functional units of object-oriented programming. Then comes the concept of encapsulation, which means we want to protect our data. We want to decide how the control of updating and accessing of the data should be using the access modifiers, whether we want to provide getters and setters for a particular attribute or not. We want to decide what should be private, what should be public, and what should be protected in case we want it to be inherited and used in the child class. Then comes abstraction. We want to expose a user-friendly interface so that the user doesn't need to worry about what the implementation is. They just need to know the definitions of whatever public interfaces we are exposing, and they should be good to go with it. Then polymorphism. Now polymorphism is sort of a gift. It's not a fundamental thing that we should be implementing. Okay, it's not a must. It depends on our use case, how we want to do, and we will be covering that part in this particular module. We will see in this particular project, we will see like how the classes can have overloaded functions or overriding functions and so on. I will keep that as a surprise, and like you can just make a guess if you want to right now that what all parts can be overloaded in case of our system, what classes are there, what functions we can expose, and so on. And lastly, inheritance. Now, inheritance is a crucial part of object-oriented programming paradigm because we want to reduce the redundancy in our code. We want to modularize our code in such a way that the parent class covers as much common functionality as possible, and then the child classes which are inheriting from the parent classes have the necessary required interfaces or have the necessary required attributes which they want to be covered. For example, like in vehicle parking system, we can probably have child classes like cars, bike, or trucks. I am not sure if trucks should be parked in a parking lot like movie theaters and so on, but cycles probably. So we can have such child classes which can inherit from a common vehicle class, and then we can use inheritance for that purpose. So these are the 6 dimensions of object-oriented programming in C++, and we are going to be working around all of them. So now let's decide on a class diagram, like what all different classes should be there, what all attributes should be part of our classes. So the first one, which is like the most intuitive one right now, since it's a vehicle parking system, vehicles and parking lot, like both of them are must, obviously, right? Vehicles is one class and parking is another class. Now what do we need in a parking class? We need the number of rows, right? Like what is the size of the parking is important for us to decide how many vehicles can occupy the parking and so on. So rows should be there. Then spots per row, probably something like that. And what all can we have? Obviously we need to have a grid in place so that we can store the vehicles which are there in the parking. So we can have a 2D grid. So in this case, we can use probably vectors to simulate that part, but in like just to name it, it should be a grid. So this is an integer, just to label the data types. Both of them are integers, and this can be a vector of vehicle class. Like we can use pointers to the vehicles so that we can have the luxury of runtime polymorphism whenever we want to. If you didn't understand what I said just right now, do revise to the module 3 of C++ course where I talk about polymorphism and runtime polymorphism in detail. Okay, so I think these attributes are sufficient. Now what all member functions should be a part of this particular class? We can have create parking, obviously, like that should be sort of a constructor for us. So we can use create parking, and it should actually take in the number of rows and number of spots per row, and then we can create the grid of that particular size so that we can store vehicles in it. Then we should have find vacant spot, because that was one of our functional requirements. So based on the values inside grid, whichever is a null pointer, that should, like whatever first null pointer we encounter, we can return that value. So find vacant spot. Okay, this can be one of our member functions. Then park can be one of our functions. Leave can be one of our functions. Inside leave, what we can do is probably we can calculate the time taken by that vehicle and calculate the parking fee as well. So these functions are good enough probably. Now moving on to the vehicles part, the first attribute, like one attribute which is important to have a decent mapping between the vehicles and the parking, is the cell in the grid where it is stored. So row number where it is parked and spot number probably. So this tells us the exact place where the vehicle is parked, and then we can also have a parking start time so that we can calculate at the end whenever the leave function parking is invoked, we can calculate based on the start time and based on whatever the current time is, how much time did it actually take. Okay, so we can have a parking start time. So both of these in the case are integers. For parking start time, we can probably use the Chronos library. So I also don't remember the exact syntax, so I will be Googling while designing, while actually coding it. But just a hint is sufficient over here that we will be using Chronos library. Okay, I don't remember the exact data type for that, and that is not expected out of you as well, because this is an unconventional library which we don't frequently use. So now, what all different member functions should be part of this particular class? So first of all, maybe this can be inherited by different classes, like car in this case. Let's start with car, then we can add other vehicles as well in the future. So that's how the extensibility of our class diagram will come into play. But what all functions should be there in the base class itself? Let's say vehicles is a base class, then row number, spot number, and parking start time. I think these are good enough to be kept in the base class. We don't need to like redundantly mention them again in the child class as well. The child class can directly use it from the base class vehicle. So now some of the functions which we can use is occupy spot, whatever, like when we do find vacant spot, we will get some We will get a pair of row number and like whatever column number it is, and we should probably occupy that space. So occupy spot, wherein we will get a row number and a column number, and we will take that particular place. Occupy spot, vacate spot whenever we leave the parking lot. Then this should also be common. It doesn't matter if it's a car or a bike. Both of these can be kept in the base class itself. Now after this, what do you think we should keep in the base class? Probably calculate parking hours, because parking hours is going to be the same, because since we are storing parking start time in the base class, we can calculate our parking hours in the base class itself. Calculate time. Okay, I'm just writing it because I don't have a lot of space here, but calculate time in this case. And for this, we will use the Chronos library once again, based on whatever the time is there at the time of leaving the parking, and whatever the parking start time was, we'll calculate the difference, typecast it into hours, because I want to go ahead with hours, and then we can calculate the time. So now, two of the functions which come to my mind, which we can classify as virtual functions, and like we would use pure virtual functions in this case. Don't worry, I will explain what exactly I mean by pure virtual functions. So what are those classes? Calculate fee. So in this case, for bikes, there will be some different type of fee. For cars, there will be some different type of fee. So we will mark this as virtual, and we want this to be a pure virtual function. So just to notify you that equal to 0 is used to make a virtual function pure virtual function, and this will in place make the vehicle class an abstract class. It's not required to understand what exactly pure virtual functions and abstract classes are, but abstract classes cannot be used to create objects, first of all, and if there is an abstract class, you need the child class to actually implement those pure virtual functions. Otherwise, the child class which inherits from that abstract class also becomes an abstract class. So if you want to create an object for that child class, you need to provide implementations for these pure virtual functions. So calculate fee can be used, and we can also create another virtual function which will be for get type. Okay, what type of vehicle it actually is. And now you might be wondering, why do we care what type of vehicle it is? Like, we are not having any bias for like whether some spots are reserved for cars or some spots are reserved for bikes and so on. But this is for future extensibility purpose, in case when we add bikes as well, and in case we have some reserved spots in the parking like we usually have. In a real parking, there is a designated space for two-wheelers. There is a designated space for four-wheelers as well. So right now we might not need it, but it's good to have like get type, what type of vehicle it actually is. And this actually we can provide, like instead of making them pure virtual functions over here, we can provide them in child classes as well. But keeping them as pure virtual functions in the base class forces the child classes to implement them. So maybe whoever the author of bike classes, they might miss out on it. So here we have provided them as pure virtual functions. So they will be forced to implement it so that we don't miss out on important public interfaces. So this is also defined as a pure virtual function. And I think at this moment, these are good enough to go. Like we can inherit from the vehicle class. We can inherit a car class and a bike class in future. We will start with a car class. And if we get time, we can also implement the bike class as well. It should not be a big deal. In the car class, we need to provide implementations of calculate fee and get type, and any other attribute that we want to add, but I think we might not require any other attribute. So yeah, I think there is no requirement for adding extra things. We just need to implement the pure virtual functions. So now this class diagram is good to go in my understanding. Probably we can have like, in this particular system design code, I'm not going to actually make an implementation of a payment system wherein some payment or some transaction actually happens, because we don't have any payment gateway. We don't have any facility to keep accounts and everything. So as an extension to this, you can probably cut out the payment part from the vehicles and create a new class, which is vehicle payment, and probably create child classes which inherit from the vehicle payment class, and the child classes can be car payment, bike payment, and so on, in which we will have the special formula of calculating the parking cost based on the parking time. So now let's start coding. So let's create a file, parking.cc, okay, parking system.cc probably. So we'll start with our header inclusions bit/std c++.h. Now this is a header library which I did not talk about in the C++ modules. So this covers all the functionalities which are provided by the standard template library, so that I don't need to explicitly include the Chronos library or the library for vectors and so on. This does the work for me. I can use the namespace std in this, and there will be an int main function. Now let's first start with talking about our classes. So the first class, let us make it vehicles, because if you notice over here, our parking class depends on the vehicle class. Like, we are using vehicle class in the grid attribute, so we will need to define the vehicle class first, and after that we can provide the definition for parking class. So now this attributes, I want them to be private, because I don't want anyone to randomly change the row number and the spot number. So I will have row number and spot number. Now I don't remember the implementation, like whatever the data type is for parking start time. I will just comment it right now, and I will Google it at the end whenever we want to wire everything up. So parking start time is an attribute which is remaining. We will add it soon. Now some of the public interfaces that we want to provide. We will start with the constructor first. So if you notice, we have provided row number and spot number as integers, so that default values will be 0 whenever you initiate that particular class. So we actually don't want the row number and spot number to be 0, because then it would be a valid parking spot. So whenever a vehicle is created, the row number and spot number should be some non-valid value, because they are not parked yet. Okay, they have just entered the parking system, but we have not yet assigned them to a proper parking spot. So let them be -1, right, to get started with. Now if I look at my class diagram, we have occupy spot, vacate spot. So I think this should be simple enough, unless something comes up while implementing the parking class. So the return type for occupy spot should be void, because we are just updating the values of row number and spot number. So in this case, we will get int r for row and int c for the spot number, and we will update both the values. Now if I'm making any mistake while coding, do write in the comments. I hopefully would be able to resolve it while this live coding session is going on. And also a fun activity for you. I will keep on compiling at regular intervals. Your task would be to calculate the number of times the compilation fails before the actual code runs. Okay, and let me also start the timer in my mobile, so that I keep a track of how much time does it actually take me to code this thing. Okay, so I'm just starting my stopwatch. I just begun it right now. I will add 2 to 3 minutes because I have already coded something. Okay, so occupy spot is done. Now when we want to vacate spot, probably at this point it is safe to consider that, like, the parking class, whatever the interfaces we are providing in parking class, they will manage whatever duration it took for the vehicle, like whatever duration the vehicle was parked for and so on. So in this case, we again have the void return type, and for vacate spot, we don't require any attribute, like we don't require any parameters. We can just make the row number and spot number to be invalid once again. All right, next we have calculate time. So that I will just comment it over here because I'm not aware about what the exact functionality is provided by the Chronos library. So I'll just comment it. I don't know what the data type is, but the definition would be calculate parking duration in hours. Okay, in hours. Now, does this require any input parameters? I don't think so, because we already have an input parameter, like we already have an attribute which keeps a track of what our start time was. So we can just mention in comments over here, use parking start time and current time. Okay, this is just a hint for me whenever I am actually implementing this part. Now, if you notice, calculate fee and get type, both of them are virtual, so we need to still like mark them as virtual, pure virtual functions. So calculate parking fee. Now this is the nomenclature for marking a function as pure virtual function, and this will be get type. I have missed out on the return data types, so this will be integer. Parking fee can be double actually, or let's keep it integer for a whole number. Let's not add a lot of confusion here. And get type can be string, like it can be a car string, it can be a bike string, and so on. Now, I think this is good enough for the vehicle class. I will just take a look in some time after I inherit the vehicle class to a car class. So let's define the car class. It will have a public inheritance from the vehicle class. And also one important thing to not forget is the semicolon after the class definition, which I usually forget. I hope you won't be making the same mistakes that I am making. Now, I don't think we require any private attributes in the car class because we are not storing things like what are the number of wheels and so on. But in case if we require in future, probably let's do one thing. Let's have one private attribute which says int. I think this is also constant, so private attribute is not required. What I was thinking was maybe we can define a private attribute which is like a parking multiplier. For example, we can have 5 times the number of hours for cars parking fee and 2 times the number of hours for bike parking fee and so on. But since that is a constant, we don't want to keep on updating it. Let's keep that as a constant. Now let's first implement the virtual function. So get type, and this will just return car in this case. Now calculate fee is something which we will do based on like whatever the duration is. Calculate parking fee. Okay. Now how we can do this? We can just call the function calculate parking duration in hours. Okay. And this actually, the data type here should be integer. Like we will convert it inside the code itself, but it should be integer. And let's also define it. Let's just keep it vacant. Let's just, yeah, this is good to go because this will provide us an interface even though it's an empty one. So right now I will just replace it with return 1 in this case. Okay, we will replace it soon. And in this case, we can return 5 times calculate parking duration in hours. Okay. So this feels a good place to like complete our definition for the child class car, which is inheriting from the vehicle class. Now we have inherited both the dependent classes. Now we want to define our parking class, which will use the vehicle class. Okay. Now, one important observation is the parking doesn't know what type of vehicle it is at the moment. In case we want to extend it in the future to like have some designated spots for cars and like other types of vehicles, then we can use the get type functionality from the vehicle. And using that functionality, we can let the parking decide whether this parking spot is a valid parking spot for a car or not. Right now, it's not required. Right now, all the vehicles are neutral for the parking lot. So we don't require it. Class parking. Now what all are the attributes? Some of the private attributes here are int rows, like how many number of rows are there, integer for spots per row, and then we will have a grid which is a vector of vehicle pointers. Okay, why we are storing vehicle pointers and not vehicles? Obviously one thing is to occupy less space, because pointers will occupy only 8 bytes, right? And we can directly access the attributes from the pointers. But if you remember in the module, in the C++ module of object-oriented programming, I talked that we can use base class pointers to enable runtime polymorphism. So that will be very evident from the code that we will be writing in future. So this will be the grid. Now let's write the public interfaces. Okay. Now we will, first of all, this is a sort of constructor. We can have a proper constructor with the name parking, but I want to make it more user friendly. So we'll have create as the input, and in the input we will have int r and int c for the number of rows and columns. And we will first of all assign rows to r and spots per row to c. And then we will also initialize the grid. Okay. Now grid dot resize r. Now these are some of the functionalities which I'm using from the standard template library, like resize. So that I can, like, at the runtime I can decide what should be the size of our 2D vector that we are using. Now we will run a for loop to create space for all the spots per row, like we will initialize the grid for each row. Grid of I dot resize C. So at the beginning all of them will be null pointers. Okay, and as soon as we start parking some vehicles there, they will be storing the address of that particular vehicle pointer. Now let's implement find vacant spot. Now what should be the data type of this? It can be a pair of 2 integers which will store the row number and the spot number within that row. Now what we can do is we can just iterate over the entire grid and find out wherever it is null pointer. Int I is equal to 0, I less than rows, I plus plus. Now right now my objective is not to write a clean code, so apologies for that. My objective is to make sure that this time is as low as possible. Int j is equal to 0. This is a nested for loop to iterate through both the dimensions of our parking. Now if grid of I comma j equal to null, now this is what happens when you don't code in a particular language for some time. You need to play around with different permutations and combinations. Now in this case, what we'll do is we will return the tuple, or we will return the pair of I comma j. Okay. Now again, I'm not sure about this syntax. Maybe it's round brackets, maybe it's curly braces. So I will wait for the compilation error to happen and then let it guide me what the braces should be. Okay. Now find vacant spot is done. Let's implement park. So this return type also should be void, because like after parking we don't want that function to return anything. Now what should be the input parameter? It should be like what we are actually parking. So vehicle pointer we will take in as an input. Then we will find the spot where we want to park it. Okay, so find spot is equal to find vacant, and what we want is vehicle to occupy that spot. Spot dot first and spot dot second. Now this is how you access the elements from a pair. We use pair dot first and pair dot second to access the first element and the second element. And is there anything else that we need to do? Yes, we need to update the grid as well. So grid of spot dot first and spot dot second will be equal to v, which is the pointer to the vehicle. Okay. Now leave, when we are leaving, we also need access to the vehicle pointer. And at the leaving time, we already have, like, we know what place the vehicle is located, like we just need to vacate that space. But one important observation is that we don't have a public interface as far as I remember. So how do we decide what place the vehicle was located at? So vacate spot just updates the row number and spot number to -1. So first, our first task should be to identify where the vehicle is located. And here we will create, like if we try to pass the parking parameter to vacate spot, let's say we try to update the vacate spot functionality in vehicle, then we need to like pass the parking grid as well. But if we pass the parking grid, then it becomes a cyclic dependency, which is not valid. Like parking class will depend on vehicle class and vehicle class will depend on parking class. So other thing which we can do is we can just move around the grid and then we can match the pointers with the vehicle pointer. Let me show you what I actually mean. If grid of I comma j equals to v, it means that it is parked over here. Okay. Now if there is an equality, it means the vehicle was parked in this particular place denoted by row I and spot j. Now the first thing that we want to do is we want to empty the grid. Grid of I, j should again be null. This shows it's empty, and we can also vacate spot. How we can use the pointer to the vehicle. So this should probably vacate the spot. Though this is not optimized, we are again going through an n square loop, like whatever the size of the parking is. But probably due to the cyclic dependency, we are not left with any choices. You can let me know in the comments if there is an optimization to this. I would be happy to hear it. Now we have implemented all the 4 interfaces. Now this is not actually required, but I just wanted to show how a method can be overloaded in the class. So what we can have in park as well, we can just have the places, row number where we want to park the vehicle, and int for spot number. And what we can do is, first of all, if we want to occupy the spot, we will pass these parameters. Occupy spot. And so if you see, since I have overloaded the park function based on whatever the definition we are using during the function call, we will take a call, like the compiler will take a call which function should actually be called. Row num, spot num. Now I don't need this redundant functionality. I can directly call the park function that I have declared below, and for that purpose I need to define it above this function. We will pass the vehicle pointer, we will pass the row number, which is spot.first and spot.second for spot number. And I think this is good. I'm not too sure. Let's compile it first of all and be ready to count my first compilation error. Because it would be a miracle if this compiled in the first time. I never expected to compile in the first time. Okay. Whenever the code compiles in the first time, my first reaction is there is something wrong because it compiled on the first go and that usually never happens. So I'm curious, but I will let the time decide. Whenever I implement this parking duration functionality, I will just implement it and we will see what is actually happening whenever we run the functionality from the main function. So now I will just take a pause over here, quickly Google how we can use the Chronos library, and then I will see you with the updated code. Okay, so I have just Googled it and I have added the data types because obviously I didn't remember all of these. I just knew that Chronos library can be used. So this is the data type for our time, like however we are going to represent our timestamp. And if you notice in the calculate parking hours and duration, what we have done is, first of all, we found out what the current time was. And if you notice, there is an auto keyword that we are using, because like when we use auto keyword, it will try to implicitly copy whatever data type is there on the right hand side. So in this case, chrono system clock, now I for sure don't know what the exact data type is. So I will let the compiler decide what the data type to that should be. In the next line, what I'm doing is I am just subtracting the current time from the parking start time, and then I'm casting it to hours because my functionality requires it to be in hours. It can be minutes as well. You can just check out what the exact enum is for minutes and you can use it as well. And lastly, what I'm doing is I'm using duration.count to actually get the number of hours it has. So this should be good to go. Let's compile it again, and it is getting compiled, and this is actually scaring me right now. Okay, let's implement the main function and try to park some vehicle actually. Okay, so the first thing that we need to do is we need to create a parking object. So parking p is good enough for name here. Now what do we need? We don't need anything to initialize it. First of all, we can use p.create. p.create, let the parking grid be 3x2. We don't want to create a very big parking for testing it. So now if you remember, I said in the non-functional requirements that your code should be testable. So if you want to actually test it, you can just write in the int main function itself. You can create a new file. You can link this particular CC file in the test file. And then you can, in the int main function, you can invoke different types of functionalities and then assert whether the outputs are as expected or not. Okay, so I'll just create a parking of 3x2. I will create a car C1 and C2. Does it require initializing? It has an explicit initialization without any parameters, so it should be good to go. Now let's say I want to park the first car. So park, we have the park functionality exposed. So what we can do is we can have p.park, and then if you notice the second definition of park, we are using a pointer to vehicle. And if you remember the virtual functions and how we use runtime polymorphism, if not, open a new tab, go to the video where I am discussing about it, and then you will understand how this actually works. We are giving the content, we are giving the reference of the child class to the pointer of the parent class, which is a valid operation. A base class pointer can point to both the references of child class and the reference of a parent class. So we will pass a reference and not just the object. Okay. So we will use the second type of definition in which we only pass the reference of the car. And then we can try to park the second car as well using the other type of definition. Let's say we try to park it on 0, 0. Okay. Now one important thing I noticed was, let's say when it tried to find a vacant spot. Let's say if there was no vacant spot, what should have happened? We should have actually returned something invalid. Okay. And we could probably print something as well to just let the user know that no valid parking space found. Okay, such error messages are good for the user, and you should also add some logging statements for the author of the code, like which is you right now. which will help you debug in the future that what actually happened. So if you notice, where are we calling find vacant spot? We are calling it in park. Now, if spot.first equal to -1 or spot.second, okay, we can just check if it is greater than 0. That should be good enough for us. If spot.first greater than 0 and spot.second greater than 0 and spot.first less than rows and spot.second less than spots per row. So this means this is a valid spot and we can go ahead with parking. Else we will just we can just print that parking was not found. Sorry, no parking available. Okay. So now let's first try to run this code. We will first try to park C1. So what the parking lot will do is it will automatically try to find the first empty space and park it over there. Now when we run, when the line number 110 is executed, it will try to park the car C2 explicitly at 0,0. And if it doesn't match, then it should print the error. Now what I will do is I will also add a debugging function which prints the parking, because it will be helpful for us in case the code doesn't run as expected. So we'll just print the entire parking lot over here. Now the compilation was successful. If the code is also successfully getting executed, then I would be dumbstruck. We need to print the grid values because that is what is simulating the parking grid. Now let us print this, let us print the parking at each stage after it is created and after each car is parked as well. Print parking. Okay. Let us print after the first car is parked as well, and let us print after the second car is parked as well. Okay, it compiled once again, and if I run it, let me just check it again. I'm nervous. So calculate parking fee uses the calculate parking duration in hours, and I think this should work as expected because I googled it. All right. Now if you notice, first of all, it's a 3x2 parking, and in the first time itself it says sorry, no parking available. So maybe I made a mistake and this actually satisfies me, because if the code ran as expected, it would have been quite terrific. Now if we look at what is actually happening in p.park &c1, let's try to debug it from there, what is happening inside the park function. So now this should actually be returning 0,0. Okay, my condition was wrong over here. I should have used greater than equal to 0, because 0, our vectors are 0 based indexing. I kept on saying that in the module and I myself have forgotten about it. So now if you notice, something happened which should not have happened. When we created the parking, it shows an empty parking. When we parked the car for the first time, 0,0 was the first empty space where the address of the car is present. But when we try to park the second car, it is trying to overwrite the first car. Okay, which should not happen. If the car is already there in place, it should return that this is not a valid parking. There is something already existing. So now we should add something in the park code over here, which is trying to update it whatsoever. Now if grid of row num and spot num is not equal to null, we should not be parking, right? but we should not be returning no parking available, because parking might be available, it's just not available at this particular spot. Sorry, no parking available at, and let's find out the grid number as well, at row number, comma, spot number, spot. Now I think this should be good to go, and we can return it from here itself. Now how would we know whether this parking was successful or not? So possibly we might want to return a boolean over here which says whether the parking is successful or not. So we can return false in this place because this was not a successful parking, and we can return true over here because this shows it was a successful parking. And we can also print this statement like your car is parked at this row number and this spot number. Thanks for parking. Your vehicle is at. Okay, I think this is good to go. If you notice, we are returning boolean here. So let us just propagate that part, and we will return park here as well. Sorry, no parking available. So we don't require the else statement, because if the if condition is successful, we are anyways returning whatever the boolean was. And no parking available, we can just return false from here. Now this code has become really clumsy, and we need to properly bifurcate what functionality the first parking function should have and what functionality the second parking function should have. Okay, but at this moment I'm not too worried about it, and park is getting called only from the main function. So anyways we are printing something, so we don't need to worry about it. Let's try to compile and run the code again. If you notice, for the first time it says thanks for parking, your vehicle is at 0,0 spot, and it has some address associated with the first vehicle. And when the second time it tries the second car to be parked at the same space, it says sorry, no parking available at 0,0 spot, and it doesn't change the address. The address of the first car remains as it is. So now what we can do is we can try to park it at some other spot. We can let the parking system decide where the parking should actually happen. Okay, now it should actually be parking at 0,1 grid number, but let's see what actually happens. So if you notice, first time it said sorry, the same thing happened, and then we tried to park it again using the default functionality. It said thanks for parking, your vehicle is at 0,1 spot. So this is what we expected. And if you notice, the parking of the the address of the first car doesn't change throughout, so that persistence is there. Now our code is actually complete, and it is almost 30 minutes. Okay, so I will just add a buffer of 3 to 4 minutes to it, and I have completed the code along with the explanation and testing in 35ish minutes, which is a pretty good thing to do after having not written C++ code for a few months. Now how to test this we have already covered. I have talked about it. Okay, now let's just do one small thing before we wrap this thing up. What's next? Let's try to inherit another class. Let's try to inherit the vehicle class to bike class. Okay, so this should not be a tricky thing to do. We can just copy paste the car class and change it by bike. And in get type we can return bike instead, and here the parking fee can actually be 2 times the duration. Now one important thing that I probably missed out was not calling the calculate parking fee function. We have not called it at all. So when we are actually vacating, where are we vacating? We are vacating over here. So we are using vvacate spot. So instead we can, first we actually had to, before vacating the spot, we actually had to calculate the parking fee, or pay the parking fee. So that part was missing. We can implement both of them together. So vehicle pointer, calculate parking fee. Calculate parking fee, and what does it return? It returns me an integer. Okay. So int fee. Now obviously we have not implemented any payment mechanism, so it would be stupid to expect some payment to actually happen. Fee is whatever rupees are. Fee is rupees, and then a new line. Okay. Now another thing which we have not implemented is actually leaving the car. So let's do all of that together. I hope it doesn't cause any issue. Let's have just one bike. Okay. And let's try to park the bike at a proper place. Park and B1. And we know for sure that 1, 1 in this case is empty, because at the end, if you notice, only 0, 0 and 0, 1 places were occupied. So we can have 2, 1 as well. Okay, and let's print the parking after that. Now we will also execute the leave part. Let's vacate C2 first, and then we'll print parking as well. And then let's vacate C1 first and then B1. Now hopefully this doesn't crash. It compiled successfully, and if you notice, it is throwing me some jargon. That is all right. Why is fee some random thing? Calculate parking fee. What is calculate parking fee? Calculate parking duration in hours. And that should have been returning me 0, because actually there are no hours in this. So let me just print a debugging statement here. Debug time duration dot count. All right. But now let's explore the other execution. Let's check the other execution of the code. Thanks for parking. C1 is parked properly. C2 was not able to park. C2 is parked properly at 0, 1. B1, the bike is parked at 2, 1, which we wanted. And if you notice in the grid, there is another address for the bike. Now what we are doing for the first time, we are trying to vacate C2, and hence this becomes empty over here. And okay, now I realize what is the issue. The issue was when we were parking, we have not set our assigned time. Okay, parking start time is not assigned at all, which should have been assigned when we occupy the spot. Now I can just copy from here, because we want to assign it to the current time, which is at the parking. Now probably I can just get rid of the debug statement as well, because I feel I am confident that this was the issue. Now if you notice, this is getting a bit cluttered, so let's add one more empty space so that it's easier to read. Now we can add another empty line after the parking is printed. Let's compile it once again and let's run it. So initially it's empty. First car is parked at 0, 0. Second car was not able to park. Second car gets parked at 0, 1. Bike gets parked at 2, 1. If you notice, the addresses of C1 and C2 persist. Now while vacating C2, the fee is 0 because hours are 0. Because it was getting executed in real time, it would be a fraction of a second. So the hours is going to be 0. And C2 is now empty, but C1 and B1 have their addresses persisted. Now we are vacating C1 or B1, I'm not sure. C1 we are vacating first, and the fee for that is also 0, and at last we are vacating B1. So this is how the code should have got executed, and that's it for this particular project. But what I want you to implement is the last part. I'm not going to implement it. This is a take-home assignment. We want you to add designated spots for different types of vehicles. Okay, I have already provided you with the functionality of get type. You can use that to check whether this is a valid space for a car or for a bike or not. And you can also add an extra vehicle, which can be cycle in this case. Okay, I'm just giving random vehicle names. So you can just like have the cycle parked. You can inherit it from the vehicle class. And what you can actually do is you can take it from the input, like you can take it from the user, that in the grid what spots are designated for a car, what spots are designated for a bike, and what spots are designated for the cycle, and so on. And you can implement it and upload it to GitHub and share the GitHub link in the comment section below. And just let me know how it goes. I am sure you would learn a lot of things while you are implementing this part. Thank you. So I really hope you enjoyed this content and found it insightful. If yes, do give it a thumbs up. Put down your opinions in the comment. If you have any doubts, you can put them down in the comments as well. Lastly, don't forget to subscribe to Scalar's YouTube channel and hit the bell icon so that you never miss out on notifications.